goes to 250. So it cannot work on a single.
Sorry, you're segmenting pricing based upon my location?
Yeah, it is.
So where do I have to live to get the best deal on permanent products?
I'm not good at that. And
is that legal?
see, I think the very important aspect is there's a day and time, right? What kind of offer we want to give you.
Right.
Yeah. So we always apply that discount at the moment you enter the platform.
Okay.
So every person is not looking for the discount, right?
Right.
So for the, let's say, FT, the FT is like first time transactor. They might be looking, okay, I am okay, but we want to pass on more discount, right? Instead of saying, okay, apply this coupon, then you will get 250 off. No,
yeah.
You will get the best.
So you lure them in.
Yeah. You can say that.
Let's see how this works.
The very important aspect is it's just not about the storing all this information from one key value pair and then storing all these hashes, right? It is also boils down to the problem of how much keys we are taking to get all this information to the front end service, right?
Right.
So there's a mandate. We want to make sure that this pricing information needs to be fetched in the one go, right?
Okay. Yeah.
At most it might take 3. The reason because in the pricing you have a different segment, different location we are storing, and which is stored in a key value pair with the hashes, right?
Right.
So that really helps us to optimize first of all and shrink my data size.
Okay.
So
interesting.
And the last part is we are also very heavy user of Redis order sort. I don't know how many people are using it.
Redis what?
Sorted sets.
Sorted sets.
Yeah.
Yeah. They're incredibly versatile.
It's incredibly powerful.
Yep.
My whole post order experience work on that because in the real time my orders priority keep changing. I keep telling what needs to be hold, what need not to be hold, release the hold. So that is happening every minute.
Okay.
And with that we are able to re-rank like, okay, this order needs to be go ahead fast because what happened whenever there's we have the SLA breaching for any particular product. Let's say it needs to be delivered in 2 hours. This needs to be delivered in one day or another day, right? Let's say 2 days.
Yeah.
So all these 2 hours need to be pulled up, and all these 2 days needs to be pushed down.
Okay.
So this is keep happening on the real time, and we keep renting them, and that for that order these sorted sets are very
right. It's a really simple solution that has kind of wide applicability.
Yes.
Right. As effectively a priority queue. Is that
what
you're saying? Okay.
And I think it's a no-brainer. Like we have been using all these sessions, right, on a Redis. It's just a key value in a string.
Okay. Very good.
Everything we are using for all kind of data structure that we have been using.
I think we'll switch back at this point to talk about the vector search features. After that, I just want to kind of like move this along here. Kind of what it means for your business, kind of a summary of that, what the future looks like, what types of problems you're trying to solve next. I think specifically for you, Rishab, in the AI space or in the vector search space, I think that would be really interesting. What are some additional applications of vector search maybe? I may ask a little bit about, I may talk about our product Langcache, if semantic caching is something you've looked into, or if that's a thing that you're thinking about. Vivek, I'll probably ask the same kind of forward-looking question, and then we'll open it up to two questions from the audience. Does that sound okay? All right, and then I'll thank you both. Allison, do you have any feedback?
2 notes.
Yes.
One is that we talked to the production team. We're going to not give you the clicker so
okay.
that when Vivek, you're talking, there's not a CP actor.
That makes sense, yeah.
So they'll just default back to here, and you can give the cue when you're ready from here in 2 slides.
Okay.
The one note for you is whenever you turn this direction, it feels a little closed off.
From this whole audience.
Yeah.
So I need to stay right here and just like, okay. My feet aren't touching the ground, so I'm like a little. You guys got really high chairs. All right.
Yeah, sure.
All right, thanks.
Thank you.
Yeah. You guys can go this way.
Yeah.
How are you? Good to see you. I'm very good, thanks. Morning, how are you? Vikesh, how are you? Good to see you. Where am I sitting? Over there, right? I'll just sit on the end. Yeah, yeah, yeah. He doesn't want to do it full dry run, so we'll just do intros.
Global, सब global.
Yeah? Yeah. Okay.
इस रूम में बैठना तो
Kyle
उसके
just
साथ
leaving
जैकेट.
us. Eh, You just had it.
जाके देखो.
We'll just do an intro and, yeah, okay. Let me just, let's get to the right screen so I feel comfortable. Sorry. Who's doing this right now? Okay, are they getting to my screen? Because I think they had it and passed it. That's why I'm asking. I think I'm going Blazer. Welcome to the third wave of software. Okay, so just for us to feel comfortable, this is right after the keynote. ICICI, right? Sorry, I'm just making sure. Okay, cool. All right, thank you, Rowan and Talon, for showing us how Redis is powering the agentic era with context engineering. Now let's shift gears from the future of AI to the real-world impact Redis is already making at massive scale. Banking is an industry where speed, reliability, and user experience isn't optional. Obviously, they're essential. So that's why I'm thrilled to talk to Munish Blagan, Head of Technology Infrastructure Group at ICICI Bank. Please join me in welcoming Munish to the stage. Oh, wow. Munish, how are you?
Good, good.
Good. I think we'll only have 2 chairs when we're here, right? Cool. Do you want to do a question or no?
No, it's perfect.
Okay, you good with this then?
Yeah, this is done with it.
Okay.
Yeah.
Anything else you want to feel comfortable with?
No, nothing, I guess. Yeah.
Okay. We got water.
Yeah.
We're good. I got it right? Munish Blagan.
Yeah.
Right? Okay.
That's perfectly fine.
Okay, cool.
I'm so sorry. I was trying to do 10 things at once. So at this point, it will be just the 2 chairs.
Yep.
Yeah. So I'll just move it. Yeah.
So we can see exactly where you're going to
Yeah, this way. Yeah.
Cool. I'll have these. Like you and I talked about, I'll stick to the questions unless I double click on something that you said, and I just want you to kind of go
Revalidate it.
deeper on it. Does that make sense?
Yeah, perfect. Yeah.
And then, normally a good wrap is like any clip.
Hey, check, mic check, check. Okay ಅಲ್ವಾ? Check. Hey. 1 2 2 2 1 2. Check 1 2. check, check, hey, hey, hey. Okay ಅಲ್ವಾ? Check, 1, 2, 2. Check, check, check.
In my heart, I'd surely not break you if you were beside me, and my love would take you. I'll keep you in safety forever, protect you. I'll hide you away from this world you reject, and I'll hide you. I'll hide you. I'll hide you. I'll hide you. If you were in my heart, I'd surely not break you. If you were beside me, and my love would take you, I'll keep you in safety forever, protect you. I'll hide you away from this world you reject, and if you were in my heart, I'd surely not break you. If you were beside me, and my love would take you, I'll keep you in safety forever, protect you. I'll hide you away from this world you reject, and I'll hide you. I'll hide you. I'll hide you. Blow the candle out, or we'll be here for days. We've said all that we need to say. Focus on my breath, listen to my chest. Let the pressure fade away. I don't wanna talk anymore, I just wanna believe that every time we touch, that we touch is a sweet relief.
All right. Good morning, everyone. Yeah. I love it. We got a big day in front of us. Let's do that one more time. Good morning, everyone. Welcome to Redis Released Bengaluru. This is our second stop on an 18-city worldwide tour, all right? So we couldn't be more excited to be in India. In all sincerity, we were here about 12 months ago, and the passion that we feel from this community, the energy and the knowledge that we feel from this community, and the feedback that we get from this community energizes us all at Redis and brings us back to be better and better each year, all right? So thank you all for attending Redis Released. More equally importantly, thank you to our sponsors, AWS, Microsoft, and Google. Please take the time to check out their booths in the expo hall, and don't miss the Microsoft session, okay? We have an Azure managed Redis session, which is built for speed, scale, and real-time apps on Azure. So anyone in the Azure ecosystem, please make sure that you go to that breakout session, okay? Look, we've got an action-packed day, including demos, customer stories, panels, and most importantly, an exclusive look at our roadmap delivered by the folks that built it, all right? But let's get going. Everyone ready? All right. So welcome to the stage, our CEO, Rowan Trollope. Rowan.
Thank you, Spencer. Good morning, everyone. Well, I am thrilled to be back in India. I've been here many times, and every time I come back, it just feels like things are getting more exciting, bigger, more interesting, more people, more fresh faces, more talent, and it's just incredible to see. In fact, this is the biggest event that we have of the year. We do this all around the world in all the big countries that we serve, and this is the most exciting and impactful event for us. So thank you, all of you. Thank you very, very much. A big round of applause. We've been growing our team and our investment here in India. We've doubled the team size just in the last year. We're now up to over 130 people here in the organization. So today we're going to talk all about the future of artificial intelligence and where we see our role in that, and share a little bit about what we're working on and some of the new technologies. How does that sound? Okay, let's dive in. I'm going to take you back 30-something years ago. I'm dating myself. This is actually, well, it's a reproduction using Google Nano Banana, if I'm being very honest, from the 1970s when I was a kid. Actually, it was the 80s. Got my first computer, which was a TI 994A, I think. My dad bought it at a garage sale. Didn't have any storage, so I had to plug it into the TV, and I couldn't, my family wouldn't be able to turn off the TV for a week after I got my computer, because as I started to write my first computer program, which is what you did when you got those computers, I couldn't turn it off because I would lose the program. And I remember really, really well this feeling of like excitement and awe and wonder that was actually like, I couldn't sleep at night that first night. And for several nights thereafter, I was just spinning, my head was spinning with ideas. And you know, yesterday we had an incredible customer dinner. We had some of our biggest customers, some of the most forward-thinking engineering leadership in India at a dinner last night. And I could see that same level of excitement, that same level of passion about what's possible in the future with AI. And so that's kind of getting me up in the morning every day with a spring in my step, and I can see it here with all of you. So really, really exciting, and it's exciting to think about what we can do to make your life easier and to make it possible for you to deliver great technologies. Now, Andrej Karpathy, anybody who's here has heard of Andrej Karpathy? Okay, he's one of the leading lights in artificial intelligence. He ran the Tesla AI team. He gave a talk at Y Combinator's kickoff day, demo day, recently, and he talked about the 3 waves of software. And I thought that was really an interesting way of framing what's going on in the industry, and then also putting things into context, because I think most of you are developers. Hands up if you're a developer in the room, engineers. Okay, so good half or more of the room. So I'll just kind of walk you through a little bit, but he talks about this 3rd wave that we're entering into of software, and he calls it Software 3.0. So what were the first 2 software eras? The first era is kind of back to where I started, right? Where you give sort of instructions in a programming language that are very deterministic, and the computer does exactly what you tell it to do, which as engineers, and for myself personally, I love that, right? You tell it what to do and it does it. It's really nice. People don't work that way, unfortunately, but computers mostly do. And so we saw that was really the way of writing software. Frankly, up until just very recently, this is the way that almost all software got written. And as a result, we built up a set of sort of architectures for delivering software that was sort of hand-coded with specific static rules. And Redis fit into that picture very nicely. In fact, in 2010, when we got our start with our open source kind of launch, was around the birth of the cloud mobile era and distributed systems and distributed, applications that needed to run at massive scale, right? You started to see these big internet applications, Instagram and WhatsApp and all these applications that almost every single one of them relied on Redis to deliver their technology to their end customers, okay? Like many of you do. And so the killer app that put us on the map at that time was caching. Was the hard problem at the time was databases are slow, and apps you're gonna have to have millions of endpoints connected to your legacy databases. How do you do that? You put Redis in the middle. And from there we grew. We grew over the last 15 years, expanding into more and more and more use cases where, we weren't a database, but we weren't the app. We were this thing in the middle that kind of was like a data platform, and it was a bit hard to describe actually what exactly Redis was, but the growth kept happening. And more and more and more and more people kept using Redis. And we stayed true to the values of the company throughout that entire time, investing in simplicity and ease of use and reliability. And that's why we now today are one of the most successful open source projects of all time, and that's thanks to all of you, the developers, who know and use and love Redis. So thank you very much for that. Now, Software 2.0, fast forwarding, sort of the introduction of machine learning, if you will, was where machine learning started to be able to take a lot of the work off of our hands, where we don't have to write all the rules. And one great way of explaining this is looking at self-driving cars. Early day self-driving car code was a lot of rules. See a green light, go, see a red light, stop. Now, I don't see a lot of red lights or green lights here in Bengaluru, which is a little horrifying, actually. I don't know how you all don't get in more accidents. It's pretty awesome, though. And I will be very interested to see how self-driving cars do here. Is anybody curious about that? I am. Maybe they'll be good, but I don't know. But in Software 2.0, you saw the ability of essentially training a model to be able to take over all of those rules. And now, with the most recent version of, let's say, FSD 13, I think it is, from Tesla, we have an algorithm that basically has very few hand-coded rules, and that machine learning algorithm has just been eating through all the manual software that was being written for the last 15 years. So pretty interesting. And in that world, we played a pretty important role because we was a real-time feature store. We also built a vector database, so the introduction of machine learning created the need for a new fundamental data type in Redis, which is a vector. And many of you are all learning about and starting to implement vectors and using our new technology to do that. So we had our place there. And that brings us up to the present. And boy, this is a big change. I mean, it pretty much, large language models, what we saw, and it's sort of popularized by ChatGPT in February of last year, was just a technology that fundamentally is going to change the way that all of us build software, the way that we deliver software, and frankly, the way that the world works. And it's really, really exciting. So there's two big things, at least from my perspective as a developer, that I think about how large language models and this new evolution affect sort of my daily life. One is it changes how I write software. So I'm writing less software and I'm having AI do more of the writing, which is great. I mean, it takes a lot of the heavy lifting off of your hands. Now, sometimes that can make me dumber, but that's okay, I suppose. But it also lets you be way more productive. I'm sure many of you are using Cursor. I mean, in our dinner last night, it seemed like everybody is using that. We did a little informal poll, and somewhere between 30 to 50% of the software that these leading companies are writing is now being written or contributed to, at least, by AI. Now, there's a lot of proclamations about that number going way up, and then there's a lot of high-speed hand-wringing going on about, well, what does that mean for entry-level developers? I think it means there's going to be a hell of a lot more software written in the future. And I think that all of our jobs are going to be safe as long as we stay at the cutting edge of using that technology to be as productive as we possibly can be. But it's really exciting to write software using the latest tools. The other big thing that large language models have enabled is a new architecture for software that we're all calling agentic AI. It's the most popular term for this new architectural model. And I know a lot of you are already building agents or have tried it or starting down that path. So the way that I think about an agent or agentic AI, because it's sort of still very early in terms of the terms and definitions here, is that fundamentally the new piece we have to work with is a reasoning engine, the large language model. And with the introduction of tool calling, where the LLM can be given a set of tools and told, here's what you can access, and here's how you can get data, and here's how you can actually change state, that really makes for a very, very powerful system, where you can now call the large language model with a high-level task. Hey, you're a travel agent, we're booking a trip to Paris, here's the user, here's their profile, here's some other information, you've got a tool, a booking app, a weather tool, an API here and there, et cetera. Go do it. And it goes off and does that process. That is a fundamentally radically different way of writing software, and it's quite hard to wrap your head around it, but it's really, really interesting. And there are a new set of challenges. It sounds easy when you describe it that way, and really powerful, and we can see that there are early examples of incredible agents that are being written, mostly in the coding tools, Claude Code, Codex, Replit. Really, that's where the main, you can see production level examples of agentic AI starting to hit the market. Really, really interesting. And I'd say there's a new Moore's law that has emerged. Most recently, I'd say even just the last month, people are now measuring this new Moore's law, which is how long does it take for the amount of time an agent can run unsupervised without going totally off the rails. And that time has been increasing by orders of magnitude over the last couple of years. So when we started, it was not very long. Now I think Replit is claiming their agent is up to 200 minutes. OpenAI version 5 is now claiming very, very long uninterrupted runtime. So this is really, it's hearkening to this, it's calling us forth to this really, really interesting and powerful future. Now there's a new set of problems that emerges in this world of agentic AI that we're focused on. So there's lots of new opportunities, but I want to focus this in on the hard problems where Redis is where we think we can contribute. And the big one is a new term that's emerged called context engineering. And context engineering is just very simply dealing with the fact that large language models themselves are frozen in time. They don't learn as they, as you tell them and interact with them, right? They don't have any memory about what you've said before. They have to be given that memory. They don't know what the user has said or what they've done or anything like that. And so there's a lot of work for us to do to provide all that information. That's one problem. Second problem is they don't have information, let's say proprietary information from your company. They don't know who you as a user are. So they have to be fed all that information into the context window. And getting just exactly the right information at the right time into a limited context window. Now context windows are getting bigger, but that is a different opportunity and problem set. But getting exactly the right information into the context window at the right time is a new and emerging problem. And it's one of the harder problems when it comes to building agents that I think many developers are now running into. And this is an area where we think we can help. So a few of those areas, one, we talked about over the last year a lot about RAG. We talked about RAG, Retrieval Augmented Generation. Why did we talk about that? Because LLMs from last year and this year, they hallucinate. They hallucinate a lot, but especially an agent starts to hallucinate and the problem snowballs the longer you let it go. And so you need to constantly ground it in information that is relevant. So if we're asking about, tell us about this Redis API, well, I'll tell you, they can answer generally Redis APIs, but they're much better off when you feed them the latest documentation for the Redis API for the version you're talking about, and then they can give you a great answer. So RAG is obviously emerged as one discipline in context engineering. State and history memory is probably the hottest topic in large language models right now. How do you build great memory into these systems? Remembering what's relevant about the user, what's relevant about where we are in the set of tasks that we're working on, or a complex project. Having long and short-term memory is really important, and on and on and on. So many problems exist within this subcategory of context engineering, and these are the ones that we're focused on. We're focused on really making it easy to build agents by doing the things that we are really, really good at. High performance data platform, a high scale data platform, a low latency data platform, and a low cost data platform, and a secure and manageable data platform. So that's where we are heading as a company. So to put that into context, if you go back to the Redis that many of you started with, right, the job sort of where we sat in the stack, where did Redis sit? It sat between your data at the bottom. You're going to have your primary data sources and your systems of record. That's usually not Redis. And then you're going to have Redis that sits in the middle, doing things like caching and session stores and rate limiting and messaging and all kinds of other things. And then you're going to have your application and your user. Well, in the modern agent world, we sit between the data sources on the bottom, sources of truth, the APIs, the other platforms you're going to be using, and the agent at the top, okay? So the user is now sort of buffered in between us, and we're sitting and serving the agent and providing all the right context into that context window. We're doing that, through retrieval augmented generation and our new vector database. We're doing that through short and long-term memory. You can store everything in Redis, and a lot of developers are already doing this. So this is where we sit in this new stack, if you will. Now, a recent survey was done, and it actually showed that we're already number one in this. Developers are turning to the tool that they know and love already, more than any other tool for agent data. So thank you if you're doing that and you answered this survey and said, yes, I love Redis and it's number one, because we're really, really thrilled that we're starting to get that traction. And we're learning a lot every day, and a big part of this conference for us is us learning from you. So we have a lot of exciting content to share, but where we get the value is when we hear back from you. What would you like us to do? What are the hard problems you're having? How can we help you make those easier? There are a lot of great companies here today that are, I would say, leading edge, cutting edge companies who are going to be speaking. So thank you to all the speakers, Core AI and Purple, Apna, CF Baxter, Microsoft for being here, ICICI Bank, having used RDI. We're really excited and thankful for those customers. And these are the folks who inform us and inform our strategy and what our roadmap is and what we should be working on. So as we've been down this path for about the last year, about a year to a year and a half ago, we staffed up a brand new engineering team. We made the biggest investment in the recent memory of the company's history, building a large new engineering team to start building new AI technology. And we've done a lot. We just launched a public preview of a new service built on Redis called Redis Langcache. Redis Langcache is designed to do something that we call prompt caching. So we heard from developers that, hey, especially when I'm building an agent, my LLM bills are just going out the roof. Anybody have that problem? High LLM costs, yeah, or high latency. It's a big problem. So with our new Langcache, we've built a really, really great web service that uses Redis underneath the covers to do semantic caching. And so you can pass in prompts, and if the LLM has already answered that before, we can, and it's a semantic cache, so it's not an exact match, and it uses our vector database underneath the covers. We can reduce your OpenAI or Anthropic or LLM bills, and we can also reduce latency. We've also been working and launching some new open source projects. Redis Agent Memory Server is one of the more interesting ones, in my opinion. So this is a low-level building block for agent memory. So today, what most people are doing when they're building agents is they are taking essentially all the transcripts that have, all the multi-turn conversation between the agent and the LLM, and storing that in Redis and storing checkpoints for tools and so on. But building a really, really effective and useful memory system is much harder than that. And so we've begun this new project. We're looking for contributors, so you can take a look at it on GitHub. Just search Redis Agent Memory Server, and please go try it out and contribute to it. We're pretty excited about that. It uses Redis and all the tools underneath the covers, but it provides one extra layer of capabilities to make agent memory a much easier problem. We've been doing a lot on Redis Query Engine. We've been adding a lot of capability there. We've launched a brand new data type in Redis called vector sets. So the original author of Redis, who couldn't be here today, and he was sorry about that. He was going to dial in on video from Italy, Salvatore Sanfilippo, he's also known as Anti-Res. He rejoined the company last year to help work on our AI team. And he had an idea that we should have a brand new API in Redis 8 called vector set. And so we've now got that built into Redis 8, and we're adding new capabilities. He's working feverishly on that. You can go follow him on YouTube, watch his videos. He's excited about all the stuff. He's excited about all the stuff people can build with vector sets. We've also launched a brand new product called Redis Data Integration. We have quite a few people in the room who are using it. We'll talk a little more about that at the end of the slide deck here. And then finally, we've got a lot of new partnerships with companies like LM Cache, actually helping the the underlying foundational models scale faster. So doing a lot of work there. The other big area we've been focused in, and this is again where we need more feedback, is building and integrating into the ecosystems where you are, that you're building on top of. So whether earlier ecosystems like LangChain, great agentic platform, we were first there. We're showing up in really all of these platforms so that we can make it easier and easier for you to use Redis. So that underlying plumbing and doing the hookups there, I think, makes things easier for you. So we've actually done more than 30 different integrations, from Amazon Bedrock to upcoming CodeGen tool from Microsoft to LangChain and Llama Index. We're just all over the place. So we've been doing a lot of stuff, and we got a lot more coming. But I thought what would be great is, rather than me keep talking this whole time, is we should actually dive in and show you some of this stuff in action. Since we have so many developers in the room, we're going to do a live demo. And so to help me do that, actually to do all of it, is going to be Talon Miller. So everybody, please put your hands together and welcome Talon Miller to the stage. Hey everyone, how are you? You ready?
Yeah, hello. Hello, everybody.
Now, I told Talon earlier that there was a big Facebook demo yesterday. Did you guys see that?
Oh, God.
That's not going to be you. Don't worry.
No.
We're all on your side here.
The
okay?
demo gods are with us today.
All right.
They weren't with Meta, but they'll be here today.
All right, what do you got for us today, Talon?
Yeah, so we actually do have a cool demo for you today. Rowan, you may have heard that at Redis, we've been doing a migration of our websites from our older content management system over to a new platform, essentially. And our developers who are doing this migration, they would like to work with Markdown, and we couldn't find a great solution for converting these existing pages from HTML into Markdown to do this migration. So we thought, why don't we build something? Not just to convert everything to Markdown, but maybe add something agentic to it as well.
All right, exciting.
So I think what we'll do is I will run you through the demo, and then we'll transition over to the architecture diagram where you can see what the app looks like. So first, let me just make sure and refresh everything works. Okay, perfect. Step one's good. All right, let's create a new project. So what we're doing here is using some natural language to kick off our agentic workflow. After we send this through, what's happening next is we are invoking our orchestration agent. Our orchestration agent is going to invoke our crawler agent that's powered by Tavili, who's going to grab all of the different tutorials from redis.io/learn. In this example, we've got 5 different tutorials. And then it's going to convert those tutorials into Markdown. It'll then send that Markdown over to our document agent, which is our second agent in the process. Our document agent is going to communicate with an LLM, who's going to create some vector embeddings, and then store both those embeddings and the documents inside of Redis. Once those are in Redis, we'll get the UI update, as you can see, and we can start working with it.
So just to be clear, so we have an old website, and you have, instead of doing what we would have done in the past when we write software, which is kind of a bunch of kind of specific rules and process steps, you've built agents to go do all this work. And how many agents are there? You just mentioned 3 or 4.
An orchestration agent, a crawler agent, and a document agent. So
Okay.
3 right now. But since
And this is a radically different way of doing, probably a lot of the people in the room have done something like this before. And as you were writing this, how different was it to write this than what we used to do before?
Yeah, so before we just tried to use a platform to do the migration, usually from HTML into whatever the next platform wants to use. But our developers really wanted to use Markdown, and we really couldn't find a great solution for that. So now we have the documents in Markdown, but now it's like, well, let's do something cooler with agents where we can actually teach it by example what we'd normally like to change to these
Let's see that.
migrations. So, for example, the coolest part, I think, of this whole flow is being able to teach it by example what changes we'd normally make. So we'll go into one of these tutorials, and we'll make a couple of changes. So, for example, remove the header. We will add the front matter, which is, let's add the title, and we're also going to lean on the LLM to generate an SEO description and generate a URL path. So we're leaning a little bit on the LLM here. The next thing and last thing I'd like to do is maybe convert one, like, let's see, let's convert these inline code snippets to fenced, and let's also add in like a language descriptor. Oh, one extra there. All right. Now, what we'll do is we'll send these changes off. It's going to synthesize the changes, or in other words, the document agent and the LLM is going to check the before and the after of the document and try to infer or determine what changes we made, and then tell us, hey, it looks like you have these markdown editing preferences, is what we're calling it. And then we can save them to long-term memory in Redis for applying them to the rest of our documents for our migration.
All right. So using the reasoning capabilities to say, what did they do, and create rules.
Exactly. So
That's pretty awesome.
just like this, so it looks like everything's working good so far. Our agent and the LLM were able to determine that, okay, looks like we want to add some front matter, generate a SEO description and a slug, remove the header, and convert our inline code snippets to fence
How
scripts.
much work were the prompts to get it to do that right? Was that a lot of work?
No, the LLM is actually pretty good. The only thing that it sometimes can mess up on is adding a couple of extra things here, where it's like, I didn't want those changes, and it's trying to suggest things.
Too helpful?
Too helpful. It's trying too hard.
Which one are you using?
We are using OpenAI.
Okay.
Yeah. And then, so this next part is important because once we apply all changes, it's not only going to make those changes to the rest of our documents, but it's also going to save those preferences in Redis as long-term memory. And this can take a minute, so let's go into Redis Insight and take a look.
So what does that mean, storing it into Redis's long-term memory? What's it storing?
It's storing the actual long-term editing preferences. So if you take a look right here, in Redis Insight. By the way, welcome to Redis Insight. If you haven't been here before, this is our great companion
brand new.
tool.
It's awesome.
Yeah. This is what the long-term memory looks like, right? So we have a question, which is what we're saying is our markdown editing preferences, and then there's all of our, essentially what the LLM and document agent has inferred on what we'd like to edit.
Is that using Agent Memory Server?
Agent Memory Server and Vercel's SDK.
Cool.
Awesome. So let's also take a look at like one of the documents. So this is what the document looks like in general, stored as JSON inside of Redis. And then when we send the document up to an LLM to create chunked embeddings, this is what it looks like as well. So here's the content and then the embedding, vector embedding. So that's what that looks like.
Wow.
Let's go back to the app. So it's making these changes. We actually don't need to wait for this to finish. So let's go into one of the other tutorials and see how it did. So, looks like it did everything, executed pretty well. So take a look. We have the title, we have an SEO description, it removed the header and a slug for our front matter. Let's take a look at some code here. And it did convert our inline code snippets
All right.
to fenced.
That's worth a round of applause.
Yeah, awesome.
That's pretty awesome.
So that's only the first part, I think, of the main challenge. The other half is actually persisting this memory across sessions. That's what makes it long-term, right? So let's go ahead and reset our projects. What this is going to do is remove all of our documents, as you can see. Let's do a little quick refresh. But our long-term memory it actually persists and remains. So if we do this just one more time, we'll go ahead and do the exact same natural language prompt. Let's find all the tutorials.
But this time it'll remember your
Let's
preferences,
hope.
in theory.
Cross your fingers, yeah. So
So how will we know if it actually did it?
we will get a pop-up that says, hey, oh, just like that. So luckily,
Hey, it worked.
the demo gods are with us. So in the app, and I'll show you this in just a second in the code, is we coded it so that if there are long-term memory preferences, we're going to provide those as an insight. Hey, would you like to apply these? Instead of having to reteach the agent every single time. So we could apply all, but I did want to maybe like add one more thing. So our developers, they could have multiple long-term memories, right? So if they go back into one of these tutorials, make another change, it could even be a change that's counteractive to some of the long-term memories that they've made before, right? Like for example, we removed the front header, or the header. What if I kept it this time? Like, how are we going to resolve those conflict resolutions? So we also thought about that as well. I'll show you that in the code. Let's go into, sorry about the breathing here. All right, so I want to show you two different things here. So this is how we actually save our long-term memory inside of Redis. Whenever we make these changes, we're going to save it in Redis, but if there's already an existing memory, we're going to merge memory. So that's how we're kind of handling our developers using this tool over a period of time, and if they do create new memories, we're going to merge them.
And it uses the LLM to do that.
Exactly.
Okay.
And the last thing I wanted to show you too, before we go to the diagram, is how we use these memories.
That's probably one of the harder parts. If you look at Agent Memory Server, the open source code is conflict resolution.
Yes.
You like this today, you don't like that tomorrow. How does it handle that, et cetera? So.
Exactly. As it grows over time too. But merging it seems to be the best way that we're doing it with our developers today. That may change as we continue to do this migration. And this is the last bit of code that I wanted to show you, which is, in the beginning of that agentic workflow, if there are saved long-term memories, let's use that pop-up with our insights to say, hey, would you like to apply these insights? If not, great, we can save and we can do more editing and more preferences and so forth. So with that, let's go ahead and jump over to the diagram and show you what the app looks like. And I'll walk you through the flow just one more time. So on the top left, we kick it off with our user input, which is that natural language prompt. It goes into our orchestration agent, who routes that to our content or our crawler agent powered by Tivoli, and then it's going to convert the HTML to Markdown, move that Markdown over to our document agent. Document agent then creates embeddings off of that with the LLM, stores all of that in Redis as like kind of a single place to create this context window for our agents. And then what in my opinion, I think is the coolest part is that learning loop, where we're teaching that agent what we prefer for long-term memories and start to apply those preferences across all of our tutorials.
Amazing. Well done.
Awesome.
Everybody, Talon Miller, thank you very much.
Thank you.
Years ago, just 3 years ago, this is a real internal tool. What I love about what the team did is they actually picked a real problem. They went and solved a real problem. It wasn't just a demo for this stage, what they're really working on. And if you were to show something like what we just showed you 3 years ago, this would have been a big SaaS company that we could have launched. This is like really impressive what you can do with this technology. So very, very exciting. And of course, Redis is a big part of making that happen, making it easier. So great job, Talon. So we mentioned earlier that we've done a lot. We're also doing a lot. We have even more things in the hopper that are coming to you. We are continuing to improve our hybrid search. So vector search has been a core part of the innovation over the last several years. We have the fastest vector search engine. We have the most accurate vector search engine, and it's one of the things that's really driving a lot of innovation, and there's a ton more for us to do, so you're going to continue to see innovations in our vector search API with hybrid search, so even more and more interesting hybrid search capabilities. We also have a brand new Redis Insight UI. We're extending that to the new data types. We're continuing to enhance our cloud product, so lots and lots and lots of things going on there. We're supporting private links, so new security options, bring your own cloud, customer managed encryption keys. We're launching Redis 8.2 in our cloud so you can get it there first, and then doing tons and tons and tons of performance improvements in the cloud, and a lot more. So these are just a few of the things that are coming in the next quarter. But the one that I wanted to dive into a little bit more here before I wrap up is a technology that we're really, really excited about called Redis Data Integration. It's a big investment for us. And what does Redis Data Integration do? Redis Data Integration, how many of you have heard about Redis Data Integration? Just quick show of hands. Not very many. Okay, good. So we talk to developers and engineers, architects, about some of their harder problems. And what we heard repeatedly, over and over and over and over and over again, was a challenge of how, it's great when you can get Redis all set up with the right data, getting the cache and validation rules all set up right, but that's not the easiest thing in the world, and you tend to be writing a lot of middleware, and often, especially in a bigger company, you're writing the same middleware and the same rules over and over and over again. It's error prone, and there are limitations when you're building a cache-aside kind of classic model using Redis. So we heard that loud and clear, and we said there has to be a better way to solve that problem. We came up with this idea of Redis Data Integration. So Redis Data Integration is a technology that uses CDC, industry standard change data capture protocol, and Debezium, which is an open source CDC server, and connects those things together with your underlying data sources, and gives you a low-code today way of defining rules to pull data whenever it changes in real time, and then stream that into Redis. Okay, and what that does is it solves this hard problem of errors and edge cases around making sure that the cache has the right data at the right time. And it eliminates the need to write that extra bit of middleware code to make sure that Redis is up to date with your backend platform. So we launched RDI in our software about a year ago. We've seen some great traction. We're going to have a talk from some of our early customers and show just how they've been able to transform their business and increase cache hit rates and actually do things that were never possible before with RDI. We're excited. We're now launching RDI in the cloud, so that's going to be in preview coming very soon. And actually today, so you can now go to redis.io and you can go to, you can sign in and then you can take a look at the preview of Redis Cloud. Really exciting, a lot of progress on that front. We have a lot of work to do. There's a lot of connectors and transforms and other things that are on the roadmap, but we're going to be investing heavily here, and we really, again, we need your feedback. So please go take a look at it. Tell us what you think. Tell us what problems it solves for you. Tell us what it doesn't do for you, and we'll try and get that onto the roadmap. We're very excited about this, so much so that we decided we were going to do an acquisition to accelerate the development even more. So we bought a company in San Francisco, great company called Decodable, who are in this space with incredible engineers, and so we've added that team now. They've recently been acquired and are part of the Redis team, and they're going to be helping us accelerate the RDI roadmap. So welcome to Redis, the RDI, the Decodable team. So the rest of our event, we have some great speakers coming up. Like I mentioned earlier, we have some of our most forward-thinking and most advanced engineering teams in the world, actually, here in India, doing incredible work with Redis. And so all of these folks are going to be here. Please stick around and attend the talks, attend the firesides, attend the chalk talks, because a lot of really, really good stuff coming from these teams. And especially if you're thinking about agentic AI, if you're building, these companies are really doing it, and they're doing cutting-edge things with Redis. So please come to one of these talks and listen to them, which kind of brings me all the way to my close. And I'll take you back to that moment, which I remember like it was yesterday, where I got that first computer and just how it made me feel inside. It made me feel very excited, and it was really a sense of wonder. And I can see that. The reason I wanted to close here is because I see that in the people that I talk to here. And I think that your country, India, is in a very special place. You know, when I first came here 30 years ago, it was really just the beginning of the tech, what would become a tech boom and a transformation of the country. And wow, how things have changed. I mean, 30 years later, many of you probably weren't even born back then. Welcome. But wow, I see that fire and that passion and that sense of awe and wonder about what's possible. And we're seeing new things that aren't being thought of anywhere else in the world, and they're being thought of first here in India. So it's very, very special what you're creating. It's really, really incredible what your opportunity is. We're glad to be a little part of that. We'd like to contribute. We'd like to help make your lives easier, so please engage with us. Thank you all for coming to our event today, and have a great day. Thank you all very, very much. Thank you.
All right. Let's give it up for Rowan and Talon. Cool. We are going to shift gears here as chairs get brought on stage. But we just walked you through, obviously, the future of AI in the agentic world. But now we're going to actually walk you through how Redis is having a real-world impact today, right, at massive scale. I think everyone in the room knows that banking is an industry where speed, reliability, and user experience are optional. They're table stakes, right? So that's why I'm thrilled to talk to Munish Blagin, Head of Technology Infrastructure Group at ICICI Bank. Please join me in welcoming Munish to the stage. Munish, thank you very much. Have a seat. Pretty good crowd, huh?
Yeah, definitely.
Excellent. Pretty good opening by Rowan and Talon, huh?
interesting times, I guess. AI is everywhere, and people are taking advantage of that.
Yeah. In one of these 16 city tour stops, we're going to make Rowan do the keynote without Talon, actually, just so you know. Just kidding. Munish, let's get going here. Obviously, I think everyone in the crowd knows ICICI Bank. Why don't you just quickly introduce us to yourself, your background, your role within the bank?
Sure. First of all, I would like to thank Spencer for inviting me over here. And it's amazing to see such a full house today in the morning, Friday morning. And going back to your question, if you look at ICICI Bank is one of the premier private banking ecosystem or bank in India. And we have been always on the fulcrum or taking advantage of technology to deliver services to the customer. And the bank is, as compared to any other international bank, possibly the banking ecosystem in India itself, we service a full gamut of banking services, whether it's retail, corporate, wealth management, and various other services. Coming back to me, I've been with the bank for last 21 years within technology itself. We didn't move to business or any other function, and have been playing different roles, starting with technology strategy, moving to infrastructure when I was managing the complete data center, cloud, network, and other things. It was tough time, but now moving back to the application world, wherein I'm managing the digital technology, the applications which are customer facing, like mobile banking, internet banking, and even the merchant ecosystem, which includes POS machines, payment gateways, WhatsApp banking, so all this stuff which comes to customer engagement, that's what I'm managing it out.
Cool, that's a lot.
Yeah.
So you just walked us through kind of a lot of the different customer touch points that you have within the bank. Let's double click on the iMobile application. Can you tell us a little bit about that?
I guess if you look at, in India especially, the first touch point to any ecosystem is through mobile.
Yeah.
And the mobile app becomes the most critical function. And if you go to any private bank, approximately 70% of our transactions happen through mobile banking. While we have large set of branches, possibly most of our peers have around 8,000, 9,000 branches, but that's how the difference is. Hardly 4 or 5% happens through a branch. So that's how important the mobile banking is there. So what we say that if mobile banking is not working, the bank is closed for you. So it is how that critical it is.
Yeah.
And if you look at coming back to the mobile, iMobile, this is our champion app, and we have somewhere around 600 plus services. And we have to ensure that we continue to modernize it out, deliver best quality and user experience to customer. There has been ups and downs, but we have been continuously working to improve our experience for the customers.
Wow. 600 services. About how many users do you have on the iMobile app?
So if you look at, if I look at the pure numbers. Oh, sorry. Yeah. Thank you so much. Yeah, thank you, Violet. So if you look at our overall numbers, the customer base will be somewhere around 50 million.
Yeah.
On an active day, we'll see that around 15 million customers accessing the app on peak days.
Wow. That is massive. So obviously you have to operate these 600 services at scale. Yeah. Talk to me about challenges you face operating and managing 50 million users.
So I'll take a step back and I'll take you what we have been as a bank we have been working on. So somewhere in 2020, when we started looking at the way the ecosystem was evolving, the UPI transactions were doubling every second or third year. So we wanted to revalidate how our ecosystem and our platforms are ready. So that's where in 2020 we started looking at our overall enterprise architecture, which made us adopt cloud, data platforms and others, and transforming our different applications. So at this stage, if I touch any of the functions which I mentioned to you, whether it was mobile banking, internet banking, or for that matter, POS or payment gateway, we as of now are rewriting those stuff. The reason being some of these applications were written, I will not call it as legacy, it has given good value to us. Legacy, I always treat legacy as good, not as bad. And it has given good value, and we are working on how we modernize it out so that we are relevant in the future also. Yeah. So that work is going on. And in mobile banking especially, because it's a kind of a marquee app, and we can't just disturb how the customer experience is there. So what we have been working is that in mobile banking, we have multiple functions. So we call it as tiles. We are replacing one tile at a time. And if you personally call me, what we call internally is that it is like doing a heart surgery when the customer is running, when the person is running. Because we are making the changes and ensuring that the app functions beautifully. Wow. We can't have a degradation of the performance or experience and then
I guess, high availability and durability?
So there are, in any organization, there are three key pillars which we work on. First is the resilience, second is the agility, third is the security. And the underplay is always a compliance. And in a banking ecosystem, compliance definitely plays a much bigger role. And when it comes to resilience part of it, we had issues because the way the mobile application was architected, we had some downtimes and we were always continuously working to improve it out. We have done a lot of work, and like in the new architecture, we are working on creating active-active setups so that the application can never ever be down. So possibly leveraging cloud as well as our data centers to make it active. And in this complete architecture, when we are transforming it out, so we rewrote the application which is Kubernetes based. Yep. And at the same time, Redis plays a very critical role in this. Because when it comes to agility and customer experience, I guess, and when it comes to responsiveness, I guess nobody beats Redis at scale. Yeah. So that's a value which come in, and the experience matters a lot from a customer perspective. There are two functions I always treat. When it comes to customer, it is the responsiveness and resilience of the app. And when it comes to the business, it is the agility part of it. Yeah. So we have to balance all and ensure that we deliver to that.
Very cool. Maybe we transition a little bit. Like, I know you're using Redis JSON data type, right? Alongside with our search capabilities that Rowan kind of briefly touched about on our Redis query engine. Can you tell us a little bit about that and how you're using that?
So I'll go back to the basics of the architecture itself. The reason being, we are running both the apps, it's coexisting, and it's very tough to when you have to coexist. And the project has taken long because of this. And the old architecture was on Oracle. So what we have done is that Redis functions for my login and the token part of it, which is very important function. Second is that when it comes to the data part, when I have to give a cache as fast as possible to the customer response, that's where we have used Redis. And for syncing data between these two, we are using RDI, which is a very critical function. While definitely it has a new product line, but it was very important for us because I can't say that, okay, you logged in from my old app, now you will have to wait for 10 seconds for the data to be replicated to the Redis cache. Yeah. So it has to be as instantaneous as possible so that the user experience doesn't take it out. So that where Redis RDA has played a critical role. Similarly, for the search and other function, we are using Redis search, which helps us to deliver that value.
Excellent, very cool. So maybe you help us understand where else you're using Redis throughout your entire stack.
So it's, if I break this one by what I highlighted to you, so what we have done is that as we were progressively moving to the architecture, so we have broken the mobile application architecture into multiple areas, bringing the business functionality or the core capability into one backend platform, we call it as Digital Engagement Hub, so that this service can be rendered to any platform, whether it's internet banking, mobile banking. So we have still a large set of customers which are using internet banking. So if you look at in India per se, mobile banking is very prominent with the young crowd, yep. But when it comes to HNI customer or senior people, they always prefer internet banking. Yeah. So I can't be saying that, okay, I'm doing something here, I am not able to provide that service to you. Okay. So that transformation is happening. And Redis is playing it each layer. First is that what I mentioned about the login, the tokenization of it, so that your sessions can be easily carried, yep. And you give required performance. Second is on the caching front, wherein we are caching the customer, I'll not say customer relationship rather, sorry. We are caching it out so that I can give the response, so that as soon as you log in it, the complete relationship about you, whether it's your credit card, whether it's a debit card, what loans you have it, the complete value can be delivered as fast as possible. That is one area which we are using it at. And search is being used extensively across various functions. So when I say it's not about only mobile banking, but the underlying complete application stack, which is the mobile banking, the digital engagement hub, everywhere the Redis is helping us to scale it up.
Very cool. So obviously,
similarly, even in core, we are extensively using Redis. Like if you say that there is core over a period of time has become very, very heavy. And what we have been seeing that 70% of the transactions which happen in core is predominantly read-only, wherein you're just checking your balances or your statement. So we are over there also we have used extensive Redis cache, wherein this is the balances and your transactions you are doing are cached in real time, and these are rendered to the front-end channels. Right. So this helps to give a much beautiful or preferred response time. What we could see earlier when the response time was around 250, 300 milliseconds, it is now kind of a few milliseconds of response time.
Wow, cool. So sessions, cache, RDI across internet, iMobile, and your
AI is
core
left.
platform. What's that?
Now AI is only left.
AI is only left. We'll get to that. We'll get to
you
that.
can bring in here.
So obviously it's been a long journey with us, ICICI and Redis. Like, how were you evaluating? You just talked about kind of current state of how you're using Redis. What was the evaluation stage looking like? What were the challenges that you were facing, and how did you make sure kind of Redis was the correct solution for that?
So their primary challenge was on resilience part of it and agility, because it was mix of architecture as well as the way the application was designed. So from an agility perspective, it has helped us when we moved, when we evaluated various solutions, and possibly we chose Redis as the preferred. I guess in the current ecosystem, whenever the discussion happens at cache, nobody thinks about anything else except Redis. So that has become de facto. If you can possibly ask any of the developer, whenever it is synonymous to cache. So that's how the Redis has evolved. And when we were designing, I guess there was no second thought about not using Redis. Redis was by design, and it is coming in all our, whenever we are doing refactoring or redesigning of applications. And beyond that, when we looked at how we can leverage, so one was the key capability was the active-active setup. Because there would be downtime, there would be issues in application, there could be outages in data center, but how do we ensure that we'll deliver still value to the customer? So that's where the Redis is playing, wherein we are trying to create active-active setups across multiple. Still working on. We have not reached to that because finally we'll have to shut down the old application when we move to. From a design perspective, it is ready, and where we will create active-active setups and be able to deliver always a quality. So for that function, it was very, very important, and the speed at which you are replicating it out across different data centers, that was a critical option for us. And second was how the data can be moved easily from Oracle, because we tried multiple solutions, it was not so seamlessly easy. RDA helped us to bridge that gap, and that's where it played a critical role in deciding some of why we went ahead with Redis for various other options.
Very cool. Thanks for walking us through that. We've talked a lot on the technology side, but you hit on business impact a little bit there. We always like to ask this question, like, how do you see the business impact that Redis has had on your customers? How do you explain that within your organization?
I guess business, for them, it doesn't matter whether you are running on a mainframe or you are running on Kubernetes ecosystem, till the time you are able to deliver quality to them and timely. So over there, what we have seen is that Redis has helped us to, when it comes to customer engagement part of it, definitely it has given good responsive app which is there. We are able to deliver good quality to the customer. There are some gaps which we are still working on, because I told that we are coexisting with the old app, and that's what we are improving it on. At the same time, when it comes to agility in delivery things, so this helps to the overall architecture plus Redis help us to deliver it much faster to the business team. So customer is also happy, business is also happy. So that's what we are trying to achieve.
Fantastic, cool. All right, so obviously a lot of ICICI customers in the crowd, I'm going to assume. Talk to us about where you're taking the iMobile app next.
So iMobile, while we were focusing more on the services part of it and others, what we are now focusing that definitely AI has to be adopted in any banking services. We are slightly cautious because we are into the area of, we are heavily regulated. So when it comes to customer engagement, we are slightly cautious what kind of services we can offer on AI. We are as of now focusing on delivering required value when it comes to searching solutions or searching services. Like a simple function which whenever I discuss with my colleagues, there's a simple feature we launched recently which was called Smart Lock, which is a very simple, easy feature saying that even whenever you lose for whatever reason or you lose a wallet, the customer is always conscious that something shouldn't happen with the banking app. So there's a simple feature, you click it and you can lock your digital footprint. So when we speak to, this was advertised also, like during IPL we had one of our leading heroes, Anil Kapoor and Samantha, which were presenting it out. But when I speak to anybody, possibly if I ask somebody to raise what is smart lock, hardly 5% of the people will raise their hand. So we are saying that why the customer should be even bothered about it. Why we can't provide a service wherein the customer, when they want, I will be able to provide service. Yeah. Nobody is bothered about all these services which bank is offering. But when I need, what I need should be offered. So that's what we are focusing on. Possibly, hopefully we'll be able to deliver to that expectation.
Cool. Yeah. It's obviously a disruptive industry, right? Yeah, with everything that's happening. Like outside of just the iMobile app, like where do you see this industry going over the next couple of years, and what are you excited to kind of be part of?
Yeah, definitely if you look at, I guess you also mentioned about it's very exciting days in India, and the way the Indian economy is growing, and possibly technology is going to be the key front which will differentiate us from any other geography. And hopefully all of you will deliver that quality to us. Yeah.
Excellent. Cool. So we got people in a lot of different stages in their probably career, their journey. You've been doing this. We both have some gray hair. Okay, so we're on that side. Like, what advice do you have to folks in the audience? Like, what do you wish you knew not like 5 years ago that you know now in terms of this journey and kind of the technology evolution that you've helped lead at ICICI?
I guess if you look at from a principles perspective, things have always been there. The enablers which are coming up, like if you look at AI as a principle has been, I guess, the core principles were written in 1960s. It's only the enablement of those principles are happening now. So this is the best time to leverage some of these technologies, principles which are being converted into reality, leverage that and deliver value to the customer. So when we are customer obsessed, I guess we deliver quality. Yeah.
Excellent. Customer obsessed. I love it. Cool. Manish, thank you for joining us.
Thank you so much. Yeah.
Any parting shots for the crowd?
Nothing. I guess the crowd itself is intelligent enough. Most of them are spending a good time over here, and we learn from each other. Thank you so much.
Excellent. Manish, thank you for having us. Very cool. Excellent. Thank you for joining us. Manish Blagan, Head of Technology Infrastructure Group at ICICI. Thank you very much for joining us. All right, cool. So we're going to move from finance to e-commerce, right? Where milliseconds determine millions of dollars. How about that? So I think we're going to have a third chair come up here, if that's all right. So please welcome Rishab Gupta from CP Extra, Vivek Puri from Purple, and our own Kyle Banker from Redis to hear how AI is transforming the digital markets. Guys, thank you.
All right. Hey, everybody. How are you doing today? Okay? Good? Interesting? My name is Kyle Banker. I've been at Redis for quite some time. I lead some of our field-facing engineering teams. We work really closely with all of our customers on building integrations, on implementing AI. We also talk to a lot of developers. You'll hear some from our developer relations team a little bit later today. I'm super excited to talk to Vivek and Rishab today. Both of these guys are architecting solutions for e-commerce at massive scale and using Redis to do it. And so we're going to hear a lot about software architectures, which I think is where Redis really shines, and hopefully go into some real detail here. So just to get started, thank you guys for both being here. I would love to just have you introduce yourselves. Let's start with Vivek. Can you tell us about your role at Purple? I know you're head of engineering, but tell us a little bit more about what that means. What Purple does. I know a lot of people here know and love Purple. I know it's a popular product, but maybe for those of us who don't know, what is Purple? And what's your scope? What are you responsible for building?
So let me first start with the Purple, because that's very important, because this is not my most strategy, right? So we predominantly serve a women category. So Purple is one of the online beauty and cosmetic marketplace. We also serve in our personal care. And while I'm saying we are online, but we have huge presence on offline as well. We already are at about 100 stores, offline stores. Then we also started quick deliveries, which is like we are promising within an hour and two, deliver a cosmetic product at your home, right? So that's what the whole agenda. We want to become a true omnipresent system, right? In that perspective. The very important aspect of what we want to do here is like if I talk about a little bit scale, like we have like more than 11 million monthly active users, right? We have more than 20 million app downloads, right? And we at Purple we serve approximately 60,000 products with more than 1,000 brands, right? Out of those 1,000 brands, we have our own private labels, right? Which means like Purple own that, and that's one of the biggest money maker unit, right? And while doing this, the objective that we are trying to serve is like we want to make sure BT should be democratized, make affordable and accessible, and personalized to each and every customer in India, which is based out of Bharat, right? So when I say the Bharat, we are not predominantly very focused on tier 1. Beyond tier 1, that's what the focus is, right? So we are serving more than 27,000 pin codes in India. You might say it is approximately each and every part of the villages and of the cities, right? So that's what it is. Like whereas I had the engineering and some part of security, which I don't want, but yeah, I started handling it. Yeah. When I'm into engineering, like it is from every aspect of it, like be it your data science, your platform, application, and that's what my purview is, right?
So mobile application,
Yeah,
as
everything.
well as warehousing, I think we talked about a little bit.
Yeah, it is.
Okay, so operating at massive scale, a lot of us know Purple. Let's switch over to Rashad for a second. Can you tell us about CP Extra? I know it's a massive scale business. I know you operate some apps at huge scale and people may not be familiar with, and also just tell us about your role.
Yeah, so CP Extra is a combination of two companies, Lotus and Macro. It's the biggest e-commerce in Thailand. I think the sister company 7-Eleven, you guys might have heard about it. We have sort of around 1 million DAU, and we sell typically, it's more of a grocery-based company. We have big stores, as big as IKEA, but we also have a lot of online services, right, including selling groceries to each and every business and individuals, right? I typically own up the search AI recommendations domain, but I also look after the cart integration and overall solution architecting in multiple international expansions that happen.
Okay, very cool. So we're going to get into architecture and what we're building more specifically. So Vivek, Redis is a big part of your stack. I know you're using a lot of features of Redis. Talk to us broadly. We'll go into more detail in a minute, but talk to us broadly about how Redis is used, some of maybe the core features, and what it's doing for different parts of your stack.
So one of the very important aspect to understand, we make it a very mandatory choice, right? Redis is going to be a very important de facto in memory cache for each and every layer, right? So when I talk like there are 70 different microservices when talking to each other, they don't talk to database or directly, or even the services, or even a data science systems, right? So the most of the time when these services are interacting, they're interacting with the Redis directly. Okay. And when I say like what it's going to happen, let's say the moment you open the application, right, all the browse, all the product, all the recommended data is coming from that particular layer. You're not directly talking to a database, right?
So everything is going through Redis when you open up that application.
That's a de facto. Like you are not allowed to query the database directly because that at our scale it is not going to help us because it becomes very complex as well for the e-commerce to really do all these kind of like where this particular inventory for this particular user, from which particular pin code you're going to serve, and which kind of category you're going to serve, right? So it's become very, I'm not saying it's not system not capable enough, but for us, e-commerce, the experience is very important. We want to serve everything under the 100 millisecond to consumer. If you don't do that, consumer might jump to some other computer, right? So that's become very important aspect.
And can you give us a sense of what your SLAs look like so that you're assuring that those customers are having a great experience?
So basically, like even for a personalization, like I didn't talk about the personalization, but let me just dive into it a bit, right?
Sure.
So for P95 for the personalization, we have 100 millisecond is the like top line, right?
Right.
So so we don't just do a personalization, like it just real-time personalization with hyper personalization, right? So you can understand, like for each and every user, we are doing a great work in the backend, right?
Right.
And it must be talking to all these constructs that we want to figure out, all these pricing, your inventory, and then what user might looking for, all the concerns, that everything is coming from that particular, right? So one more thing that we also heavily invest in, like where we definitely want to make sure that our systems are up and running.
Right.
So we don't want to shut our shop down, right? So at any point of time, you can come to the application, or even my stores as well, because stores is not like some offline POS system. It is running from my tech stack, right? So whenever I go to even a store, walk in the store, our system is just making sure they're delivering all the experience to that consumer, right? So that means we cannot shut our system at any given time.
Right.
It is okay to have stale data and take an order for that particular stale data, and for that, our de facto default is a Redis.
Okay.
So
great. So then the high availability specifically of Redis.
Yes, high availability. Like so, 99.9% is not even a question. Like we want to make sure that it's 100% because somebody walking to a store and say, "Sorry, sir, system is not working."
Right.
After some time, it's not going to work for us. Right. So that's where this capability we built in. Like whenever there's any problem happen in the system, you cannot say system keep running 100%, right? There might be some issue with services here and there, right? So the default fallback is Redis for us.
Okay, great. We'll talk more about personalization in a second, specifically. But Rashad, again, same question, kind of high-level architecture of the system and what Redis is powering.
Yeah, sure. So before we start on that, right, just to give context, right, so we have we sell around 100 million Thai baht, which is 250 million rupees every day, sort of, right?
Okay.
So from one app, right? So we had double that, so it's like 500, like million rupees sort of, right? And that means around 70% comes from search and recommendation area, right? They cannot have any downtime, it has to be resilient, right?
Right.
And it's a core experience feature. So probably first I'll go to the problem statement and then what was the exact problem, and then we can go to the architecture.
Absolutely. Let's hear about the problems first then in that case.
Yeah. So the tradition, there was a slide I think that we can put on.
Yeah, I think we have a slide up here somewhere. There we go.
Cool. So unlike the traditional English search, Thai is a bit tricky. There are no spaces between the words. So you could see, right, drinking water, the same Thai word could be broken down into multiple subwords. Now all LLMs, the search, all can basically how they work is they tokenize words.
Right.
Here it could be multiple tokens, so search becomes extremely difficult, especially if there are spelling mistakes, right? So because tokens can mean different things. So we were able to solve this. We even hold patents over this, right? And Redis is the entire search is based on Redis, from autocorrect to the vector search till the final personalization bit where we cache things, right?
Right.
So we can go to the...
so we could talk about the search architecture a little bit?
Yeah.
Is that the, okay, and we have another slide for that, I think, right?
Yeah.
Yeah, so let's talk about the search architecture, because there's about 4 different places where Redis is used.
Yep.
There's a lot of different Redis functionality that we see there. Why don't you walk us through it a little bit?
Yep. So the first is we have to serve everything within 250 milliseconds, P95, right? So let's go with this. You can see that there's a chicken which is deliberately misspelled, right? So you have, first if we see a query coming for a given user, if it's in the cache, you serve it. Otherwise, you autocorrect it. This autocorrect is based on a custom algorithm that we had written, which is based on BK tree. It takes pronunciation, other things into account. But since it's a custom data structure, there is no database for it. So you have to keep each container, each pod should have the correct dictionary. It should all, otherwise the same word will give different outputs, right?
Right.
So the idea here is there is Redis has a pub/sub offering, which can keep everything in sync, right? So it acts as an orchestrator, and it's pretty fast. It does not this query categorization and expansion models. Then you get the embeddings out. So again, the Thai does not have a good embedding models directly available. And folks are happy to suggest if you find some. So we have to fine tune all these models ourselves, prune them. We are very cost sensitive. We have to prune them and we have to create these own models on our own, like fine tune them, right? And we are talking about test fine tuning here. So then you do a vector search on the Redis. And then on top of that, what you do is, by the way, we'll discuss why it has to be Redis for the vector search later on.
Sure.
Right. So then once we have the results, then you need to re-rank them. Out of the 10,000 results, you need to find out what for this particular user who owns a cafe, let's say, what are the best results you're looking at, right? So we run a very light GBM model, which is sort of personalized, trained on these LLMs, right?
Right.
With again, which are like fine-tuned on our own logics and more on the common sense logics, and you combine all of them, take purchase data, and then you give the results back.
Right. So one thing I want to point out about this architecture is that it's using Redis in at least 3 different places.
Yes.
Right. This is the whole search architecture, and just to make sure everyone caught this, right? At the very beginning, we go in and look at a cached result, right? If we're building a search system, we're going to see a lot of redundant searches coming through, right? And so we're going to use Redis to cache all of that computation that we're doing subsequently, all of the re-ranking, the calls out to type sense, for instance, or Redis for vector search. The first step is always the cache, right? Because we want a super responsive experience. And you were saying P95 at 250 milliseconds?
Yep. With 3 different LLMs in between.
With 3 different, so it's actually pretty good given the number of LLM calls that you're actually doing. The second piece is Redis vector search, right? So we're using Redis, I'm sorry, PubSub first, okay? So PubSub, what PubSub is doing is it's keeping live dictionaries across all of your application
containers,
servers, correct?
right? Right.
Tell us a little bit more about that system. Like how many application servers are we talking? You know, how many pub/sub messages are we sending out? Can you give us a sense of the scale there?
Yep. So we have 30 containers running always, typically, give or take, right? So each of these containers will have their own BK tree inside it, some sort of a tree inside it, right?
Okay.
It's a variation of that. And then each of these will have the dictionaries formed in that structure. So whenever a word comes, a new product is indexed, new things are put in, it has to be indexed to all of these containers.
Okay.
Now you cannot have Kafka running, right? Because then rebalance, if containers expand or contract, then you have to rebalance and all that complexity. We don't need that here. What we need is, if something goes, you need a publish message coming in and you can index it to your own container.
Okay, got it. And then so we're updating all of those containers, and then later on we're doing kind of the core vector search is also happening in Redis.
So yeah, so once you get the correct word, you already have the correct word, so you know what correct embeddings you can get from it now. Because the moment the word changes, the embeddings change completely. That's the problem with the thyroid.
Sure.
So what you do is, once you have the word, you do a vector search in this Redis, right? And why Redis? Typically because of the response time, will come again on that, right? But once you do this vector search, you'll get the results, and then you do the rest of the ranking.
Amazing. So we'll talk more about that architecture in a moment. I want to switch back to Vivek and talk a little bit about personalization. So personalization is one of the main problems you're trying to solve at Purple. You want to provide a very personalized experience when people come online. Redis is a key part of that. Can you talk about where Redis fits into that, and maybe the overall architecture of the personalization system?
I think it's wrong to say where Redis is going to fit in that, because there are the whole implementation is built on the Redis surrounding that, right? So when I say personalization, right? Personalization, we just bifurcate into two parts, right? One is, first of all, it needs to be real time. So most of the time what happened, you always saw scaled personalization for the consumer. It's always remains same, right? Second, it needs to be hyper-personalized. When I say hyper-personalized, for each and every consumer is going to be different. It's not like we are bucketing you and you are going to see the same personalization what the other person sitting beside you, right? It's not like that.
Right.
So we are hyper-personalizing each and every request with the real time. So what it means to us, right? So the moment any consumer coming to the platform, right, they come with concern, or they come with some metadata, like either they're coming from the Facebook, Instagram, or Google search, or even say from the MyPN, right? So they come with a huge amount of data. The moment they land to our system, that data starts streaming to the Redis, first of all. So we have a click stream a pipeline setup which keeps streaming all these a product or user intent, which talks about what person is doing, what concern that person might have, right? And from there we keep storing, and that's where the moment we got a certain amount of all these bucket of inference data, right? We just run our ML model, then that ML model do the personalization for the user with all the preferences that we know about that consumer, and then store it back to the Redis again. Right. From there, my browsing layer always talk to that particular system, right? They always fetch the fresh data. So what happened when my ML models take that information from my first real-time pipeline, do some all these ML models, run it and store it to the system again. They have a TTL to it to make sure that we are serving the freshness to the consumer, right? With this, then we come back to the next part of it. We are just not in a business to really personalize and give you a very right result. Business also want to upsell you, cross-sell you, and we want to make money, right? Yeah. So that's where the another use come into picture, that we also understand and try to suggest consumer, okay, you might have this concern and you might be looking a wrong product, because most of the time the consumer don't know what they're looking for, right? And we know each and every ingredient what this product is all about. We know better about it, right?
Sure.
So actually come to on our platform with saying like dandruff shampoo, right? So the concern is a dandruff. Shampoo is not a product that you're looking for. You're looking to solve a dandruff as a problem, right?
Right.
So the moment we know about this is a concern, that's where there's another pipeline that is set up. My ML model keep inferencing that for the dandruff kind of use cases, how I can personalize more, all this nearby mapping of the categories, a product, and your these widgets which talked about your frequently bought, what you can do about it, what you cannot do about it, this is your concern, this is how you can solve it. Everything then restored back to that person, the user preferences data. From there, my browsing system again take it up and then serve to the consumer, right? So all these things happening in the real time.
So is it fair to say that Redis is acting as a real-time feature store
Yeah,
for
it
all
is.
of your inferencing
Everything
for
is.
hyper-personalization?
Yes, it is.
And then are you doing any caching of that personalization data, or is it always being, you talked about TTL, so it lasts a certain amount of time? Like tell us about how that
so
works.
we are not keeping anything more than 20 seconds.
20 seconds?
Yeah.
Okay.
So if I talk about a number like, so we call it the in-market action. Whenever you come to the platform, these are in-market actions.
Right.
Can I ask you just guess what kind of number that we might be storing into a system for each and every consumer?
You asking me to guess?
Yeah.
I'm sorry, I have no clue.
So we are storing more than 11,000 actions per second for every consumer.
Oh, wow. Okay, 11,000 actions per second
Yeah.
for every consumer.
Consumer.
And
per
how,
second.
how is that actually stored in Redis? Is there an interesting story there?
Yeah, so we tried a multiple ways, right? First, because there's way you can definitely make sure that you offload all these capabilities to the X source. We don't want to handle it, right? While we are getting all this thing from our ClickStream pipeline, right? When we set it up, right? Although RDA is already coming, so we just might want to remove it, but that's
Very
another
good, yeah,
question,
we should.
But then we transform it and store it as key value.
Okay.
And that key value act as a one hash and store as a user's level bucket.
Okay.
So one key, another in that key there is a hash to it. With that key, for that particular, it could be a product, it could be a widget, it could be your any kind of concern that you're looking. We just personalize each and every page for you.
Okay.
Right. So personalization is just not when you land to any a listing page or home page. I'm talking about the search as well.
Okay.
So the moment you search it, that also kicks in.
Ah, interesting.
So-
I might get a customized search result for myself,
it is.
depending on how I'm using
It's
the
very customized for you.
Okay, very cool. Let's switch gears for just a second. Back to Rashab. You know, we talked about Redis vector database, and I know you did some evaluations of other vector databases, and I want to hear what your experience was there.
So, very capitalistic comparison we did, right? Because we already use Redis from other platforms, right? In AWS and other areas, right? So we wanted vector search, and it was only available for Redis. It was only available in Redis Enterprise Cloud, right? So what happened was we checked, right? There is qgrant, there is TypeSense, there is Postgres. Postgres we already have it. So then we did Melvis, right? For qgrant with filters, it was coming around 130 milliseconds. Melvis was 70 to 90 milliseconds. TypeSense was fast but could not take the load. So of operations, because it's more of a read-heavy system.
Right.
So the only option which gave me that 30 millisecond, my golden number was that if it goes above 30 milliseconds, I cannot afford it.
You can't meet your SLAs if your vector searches go above 30 milliseconds.
Exactly. And the idea was that, let's say, if it has to be reliable, it can take the number of operations, because if it exceeds, the system goes down.
Right.
So with Redis, with 2x threading, I think it took around 30 milliseconds. With 8x, 6x or 8x threading, it takes around 8 to 9 milliseconds.
Okay,
Right.
amazing. So were there any other differences? Was it purely about latency between when you were talking about, I think you said qgrant and Milvis and maybe some other vector databases, maybe you used Postgres, I don't know. Was it purely about latency, or were there other
No,
features?
for Postgres, the problem was they do not allow storing dimensions for 4096. So any LLM
okay.
models, embedding models that you use, if you're not really quantizing to the end of it, which we could not really because of we wanted deeper embeddings, right? So Postgres was out of the option.
Okay.
Then Melvis and qgrant with the latency problem, and the other options they could not take the load that we have.
Okay, so high dimensionality data and low latency.
Just to give more context, right? We also store inventory, some sort of inventory information in our engines, right?
Okay.
So if out of stock things have to be moved out, so you're talking about 2 million updates in 15 minutes.
Okay,
So that system has to be able to take that.
got it. So you need high write throughput as well.
Yep.
And you were able to get that with Redis?
Yep.
With Redis Enterprise? Redis Cloud, which one? What are we talking about here?
It is enterprise for us. This
Okay,
particular
very
use
cool. So talking about Redis Enterprise or Redis Cloud, right? These are our core offerings that offer things like vector search and some of the capabilities that Rowan mentioned earlier. Like, what was important to you in selecting that as a platform, Vivek?
I think one of the very important aspects, right? So people do talk about like when you gonna move to from community to enterprise, it's gonna cost you a lot. But that's where we diverted a lot. We end up saving you a lot of money. Second, the very important aspect when you go to Redis Enterprise, the headache of handling all these things manually has become like it's extinct, right? Now there used to be 10, 15 folks in a DevOps team, in infrastructure dev, whose daily job is to maintain all the infrastructure, right?
So let me just clarify. So you were running open source Redis before, if I recall correctly.
Very heavily.
You had 10 to 15 people on your ops team
Correct.
that were trying to keep that up and running. So
Yes.
you needed some kind of managed service
Correct.
anyway.
So that's where now there is no single DevOps is doing that. It's been given back to the developers.
Okay.
So
Great.
developers is handling that, and they don't have an headache of like to tell them what to write setting, because all this information we are getting from the Redis itself.
Sure.
So we don't rely on it. Somebody will tell it what it's going to look like, right? The second is the uptime, right?
Right.
So uptime, as I told you, like is very, very
It's
important
essential.
for us. I cannot say, because in online people might say, okay, for 5 minutes we are back.
Right.
But on our shops we cannot do that, to be very frank, right?
Sure.
So that's where the uptime becomes very, very important, and the scalability. When I talk about the scalability, on my season days, the scale is not 1 or 2 or 3x, right? It shoot to 10x.
On special holidays, like, is this what you're talking about specifically?
No, not holidays. So in India, we are just running on holidays, this festive season.
Okay.
It's back to back from August to October is going to be
Okay.
the festival season.
Right.
We have Diwali, we have Dashara, we have Navaratri,
Sure.
we have Ganpati, we have everything, right?
Right.
So all these are the places we are going to make most of the money, right? When most of the shopping is going to happen in these occurrences, right?
Right.
So business are going to tell me like, go back and scale it for let's say 5x, because they
Right.
don't know. Because most of the time they also try to expect some of the peak traffic with some deals and everything, right? So it can goes up to a 10x, right?
Right.
And we need to be ready for it. Either you end up overscaling it up and end up spending huge amount of money, because if you're saying like 90 days you're running this festive season, for the 90-day period of time, you are over spawning all these systems, it's huge amount of money, right?
Right.
So that's where the auto scaling feature comes very
Got
handy
it.
for us, right?
Yes.
And that is saving huge amount of money for us.
Amazing. So similar question for you, Rishab, like what, in terms of just the operational side of Redis, right, running Redis Enterprise, can you tell us what your experience has been?
I mean, one of the few things, we never had any downtime after we went to Redis Enterprise.
Okay.
So it's our backbone essentially, right?
Right.
So again, I think Vivek mentioned very nicely, it can scale up, scale down,
Right.
that headache is gone. You don't have to partition it manually so much anymore,
Okay.
right? So that headache is gone, right?
Well, so you're doing manual partitioning across the previous
We would have- we
instances
would
that
have
you're running?
Community is always like that, right?
You were doing the same?
Yeah,
Okay.
in the community, like it's very hard to do that.
How do you decide which keys go, like it can
No,
change,
I mean,
right?
you're going to waste a lot of developer time basically
Yeah.
building your own manual partitioning strategy.
Exactly. So that's gone, right? And yeah, that's plus the good part is we are expanding a lot of offerings to international areas, right? So some of the facilities which are not there, like RDI is one, right?
Right.
I'm not sure if Bloom Filters is there in the open source version, but that is another one that we'll be using.
Bloom Filters does exist in open source. Actually, I wanted to talk about Bloom Filters for just a second because I think it's something that a lot of developers have a real interest in, and you're using it
Yeah.
in production right now. So
Yeah.
for those people that don't know what a Bloom Filter is, can you kind of explain that to people?
So yeah, sure. So let's say you want to store billions of keys, right? And Redis instance is cache. It's a RAM. You cannot store everything in the billion keys in a cache, right? You have to sort of you can store a limited number of keys, right? So that you don't break your build. So what happens is what you can do is each of these user keys can be mapped to a static key. And these static keys, you have a good rate of, let's say, anything that comes. You can, 99 probably you can tell if this exists or does not exist. If it does not exist, it will give you 100% confirmation it does not exist. This key is not even there. But if it exists, there is a 99% chance it can exist, right? So what does it mean? Let's say you have 2 million people coming in, right? And you maintain, let's say, users for 3 days in your cache, which is a huge amount of time. I don't think people maintain for 3 days in cache at all, right? So what you will do is, you will see, oh, this person, is it here? Or out of 2 million people, how many people will actually buy something in 2 days span? Let's say 20,000 people at
Right.
best, right?
Right.
So you can safely discard 80% of the people, 2 million people, right, that hey, these people never came to the platform or did not have any basket, and you don't have to save all those 80,000 people, like rest of the people. You only have to save limited number of cache, which is, let's say in KBs, if not MB, maybe MBs.
Right. So it gives you an alternative to storing data about every potential customer in
Correct.
Redis, right, in a hyper-compact fashion.
Correct.
We say Bloom Filters can give you a false positive, but they can't give you a false negative. So
Yes.
this is part of that family of probabilistic data structures that Redis supports.
And I don't think there is any other offering for that as well.
Right. I don't know if there's either. And in your case, like what it's actually doing, like the practical effect is it's preventing you from having to go to your core system of record too frequently. Is that
Yes,
right? Can
that
you
is-
tell us a little bit about that?
Yeah, so basically if, let's say all the 2 million people start hitting that Postgres system suddenly, then your updates coming in, your writes coming in, and with your locks happening, You take a update lock also, right? You could really choke your database. And let's say by mistake a vacuuming system, like Postgres has vacuums, you can't control them.
Right.
That runs at the same time.
Don't put it back. Yeah, you cannot. Weekends. I can tell you that.
Spoils your weekends, yeah?
Yeah. Okay. Very good. Okay. So let's move on to kind of the future. Future problems that both of you are going to be solved. So Vivek, what's next for you? What are you building next? Where do you see opportunities for using Redis? What does the future look like?
One of the very important factor that is coming in for the Redis, like in a future aspect, right? We are investing very heavily on agents. So we already deployed 4 agents in our production, and it's working very well for us. And the core underlying systems are still on the Redis itself, right? Because so what predominantly we are doing with the agents, right? There's some ops heavy work that somebody is doing, right? So you might want to update the price, you want to update, let's say, send a notification to the consumer. So these are agents are doing that, right? So, but doing that, you need to have a very stable service, because you cannot expose your APIs or database directly to the agent, because you never know what is going to happen, right?
Right.
It's a security concern, and that's what we learned from the OAuths on a hard, like it's a very hard time for us when that happened. But it's not up to the scale it's gonna hurt us, but we just learned that, right? So that's why we thought like we need to have a middle where we make sure that agents gonna talk to that particular itself, right?
Okay.
Now all these agents are having all this connection from that system, from the Redis, right? And we call it the tools, right? And now we have like 17 different tools who are making sure these agents can choose what are the best tools available for them and can get the work done, right? So with this, we are just dissecting and encapsulating the whole infrastructure, right? What is available right now and what the agent can do, because there is no right framework for us to really make sure that we are containing the agents in the manner we want it, right? The next part is like we also want a lot more investment where when I say hyper-personalization, right? Now I want to also go for one more level of hyper-personalization where we talked about like how can I hyper-personalize the store for the consumer. The moment you walk into my the store, I definitely want to understand about you as a person, and I want to gather all the input, all the key aspect, what this person have a history about it, preferences about it. So that's my the beauty advisor should talk about in that terms itself, right? So we already have the magic mirrors, everything is already there, but we are tightly integrating all this hyper personalization at rest.
Okay.
So that is a very big thing for us that we are working upon. But yeah, apart from that, the biggest win, people don't talk about it behind the curtains, right? So there's a huge workforce who is day in, day out working and making sure that you get your order delivered.
Oh, right.
I think most of us always left them behind. But if I talk about our average warehouse size is like what, 200 square meter, right? So what it means, like average the picker who picks up the order and pack it up, right, and put it in the packing station, right? They might walking for more than 14 to 15 kilometer. That's the average. It might go to 20 kilometer as well, right? So that's where we also putting a lot more all this effort. We are designing all these routes, storing in our Redis to make sure that it helps them to really walk very less to complete the order.
Right.
So, so these are the very important aspects.
So Redis is saving people's steps.
Yeah, it's very well known for
very
that.
cool. Future directions, anything else you'd like to talk about that might be interesting?
Yeah, so for us, we are doing, there are 3 areas we are actually using. One is for personalization.
Right.
The second is for inventory. And third, I'll talk about it. For the inventory, what's happening is we are pulling now the inventory for specifically for another geography we are expanding to. We pull the data from Kafka from their core systems to our database. But we cannot use database to serve the inventory for the front end, right? You have to pull that inventory into Redis. So we are going to use RDI for that.
Okay.
Yeah, finalize this architecture today morning finally. So
you finalized the architecture this
morning, yes,
for
yes.
RDI.
Yeah.
Okay, excellent.
So that's one, and another one was the personalization, as Vivek mentioned, right? I think when you do personalization at scale at real time, right? You have and you have to store the previous queries, and you have to give them weightage, right?
Okay.
And for us, we cannot use semantics directly. We have to do some things, co-occurrence and everything to take into account. So the only way which can take this sort of workload of writes and reads and serve on the real time is going to be Redis. So those are 2 areas we are going to focus on.
This is great to hear. You've heard some amazing architectural stories, amazing uses of Redis, success with e-commerce. And so I would just say, let's give a round of applause to our 2 panelists because they've done a great job today. Do we want to take any questions from the audience for Rishab or Vivek? Is everyone just ready for lunch?
Yeah, in between.
All right, great. I think we're going to invite Spencer back up to say a few closing words. But again, thank you guys so much for coming and talking to us. It's a fascinating discussion. It's great to see you seeing success.
Yep.
And good luck with everything that's coming
Thanks,
forward.
man. Thanks.
All right. Thank you so much.
Thank you.
I mean, you are lunch MC, I think.
Yeah.
So I think we'll let you.
First off, how good was that session? Like, that was worth the price of admission, huh? Let's give it up for Rashad, Vivek, and Kyle.
Thank you.
It's the most exciting I've seen Kyle in like years, man. So look, it is time for lunch right now, all right? So I think we got about 45 minutes or an hour to recharge, network, meet a bunch of people that you haven't met. We got a bunch of booths out there where you can explore demos, etc. But when we come back from lunch, we got breakouts with Core AI, Appna, and Microsoft. Thank you, everyone. Take this off too.
Good afternoon. How's everybody doing? Lunch? Good? I'll be honest with you, I love Indian cuisine. This is my first time in India in my entire life, but we eat lots of Indian food at home, believe it or not. So I'm basically been in heaven this entire week. Food's incredible. I don't know, people tell me that the hotel food's not as good as real Indian food, but I found it to be incredible. I love the fish curry, I love the roti, the flatbreads. Really enjoying it. So thanks for all your attention. We're going to jump into another fireside chat. And for that, I'd like to invite up the head of engineering at Core.ai, Girish Ankari. Come on up.
Thank you.
And give him a round of applause while he's coming up.
Thank you.
All right, so Core.ai. Girish, you've been at Core.ai for, I think, over a decade at this point. For those people who don't know anything about it, tell us what Core.ai is, but also I think I'm interested to hear kind of how the company was built up, because you've been there since quite the early days.
Cool. So, quick check. How many of you have heard of Core.ai before you came into this room? So not many. Not many. Yeah. So we are a year-old AI company founded by Raj Koneru. But mostly our R&D center and entire engineering is from Hyderabad. When I joined in around 10 years, I just finished 10 years at Core in August. And that time it was 30, now we are around 750 engineers working from Hyderabad. We have around 300 odd in US. We boast of large enterprises, our customers, like Citibank, Morgan Stanley, CVS, eBay, and many of them. So we started our journey building a virtual agent platform so that anyone can come, a subject matter expert who wants to build a chatbot for their website, both internal consumer facing or employee facing, they can come build with a no-code platform. So that's how we started our journey, building a platform for virtual agents from traditional NLP, which was rule-based NLP.
Yeah, I think that would be really interesting to talk about, because the technology has changed so much over those 10 years. Like when you say traditional NLP and the way it was working at the initial stages of the company, what did that look like at the time?
Yeah, so when we started in, it was all traditional natural language processing engine. You need to understand the language, grammar, and we were praying to the God that user doesn't type a longer sentence. User has to type a shorter sentence for us to make a meaning out of that. So from those, we started adding machine learning, deep learning algorithms for intent classification, entity extraction, named entity extraction, build a lot of our own models at Core. We boast of around 40 patents all in AI in Hyderabad, so all of them US patents. So that was the journey from where we had, and luckily analysts like Gartner, Forrester have been recognizing Core.ai as the leading, we were the leaders among the leaders quadrant within the Magic Quadrant of Gartner for our
When did that
innovation.
start? When did you start? When did you achieve that quadrant status?
So from 2022, we have been continuously been there. So 22, 23, 24, and this year too, in Forrester, hopefully in Gartner too will come in. So yeah, we started more into what we call as AI for service now. So we started our journey with ability to build your digital agents with 40 plus channels. So we had an idea where you build a virtual agent once and deploy them wherever your consumers are, whether it is Telegram, WhatsApp, email, SMS. One agent can talk to you across all these channels, and the same agent can be multilingual.
So, I think we have some slides here.
Yeah.
Is this it?
I think we
Is it good one?
passed it.
Why don't you hold it? Why don't you hold it? You control it.
Cool, thank you. Yeah, that's the Gartner recognition, guys. Gartner and the Forrester reports that we have. So we have been kind enough that, Gartner and teams have been kind enough to recognize us into this. Sorry, I think this is the slide. This is entire our 11 years of journey of Core.ai is put into this one slide. So hopefully I'll keep referring to this slide whenever you have any questions,
So right now, the core product is what is now called AI for Service, and this is a self-service chatbot, effectively, at this point.
Yeah, so the core product now is not AI for Service. AI for Service is just one of the offerings in between. So we started with AI for Service, but then we saw a lot of our customers coming back and say we also saw a lot of internal use cases for IT, HR, provisioning some of the stuff, and got a lot of feedback to build internal integrations with their systems. So we have launched AI for Work, which is for employee productivity software with which we can connect to hundreds of internal systems of an enterprise. And then this is like a single chat enterprise chat interface through which your employees can talk to all the internal systems within that. And we have recently launched AI for Process, which is for leveraging AI agents for automating your business processes, which could be there. So instead of using traditional rule-based process automation engines, you could use AI for Process for that. But the main offering, I would say, is what is in the next row, which is our multi-agent orchestration platform. Because like I was saying, we work with very large enterprises who care for security, for guardrails, safety, PII data anonymization, both encryption at rest and in transit. So our entire main platform, on top of which service, work, and process is built, is our agent platform.
To go back to something really quickly, because you said you build for a lot of large enterprises. Who are some of your key customers, and what are the successes you've seen with them?
So again, different personas. For Citibank, CVS are large customers where consumers are using. We are catering to millions of, almost 100 million calls or plus for each of these customers, both digital and voice. In case of AI for Work, Morgan Stanley has deployed agents built on top of our platform for almost 110,000 employees. Wow. Almost every employee of Morgan Stanley is using AI for Work now. And then within our AI for Service, we also have something called as CCaaS platform, which is AI first contact center platform desktop, which has a provision for you to help your human agents also handle their calls better and close those calls faster. So it helps the human agent to handle the sentiment of the user or calls, close the calls faster. So that we have eBay as our largest customer for that. Yeah.
So a lot of large American enterprise companies, which is super impressive. Let's go back into kind of the AI for category of products. You talked about AI for business processes. So can you tell me, like, what kinds of processes are you automating, or are your customers able to automate using that AI for process product?
Cool. So I'll take two examples. Okay. One is something which is huge in volume. So in typical contact centers, the calls, whether the call is taken by a human agent or a call is taken by a AI agent, these need to be audited for quality. And today's technology or yesterday's technology handles only around 5 to 10% of these calls. Randomly, they are being picked for quality, and then either the human agent or AI agent rated according to that. But then with AI for Process, what we have done for some of our large customers is ensuring that 100% of these calls, human agent or AI agent calls, are being audited for quality. And lot of insights are coming out of each of these. How an AI agent can be improved, how human agent can be improved, what topics are customers talking about, where can I upsell, what were the opportunities to upsell, where were customers referring to the competition, all that in kind of insights.
So agents has vastly opened up the possibility of kind of mining these customer service interactions.
Exactly. And another interesting use case, when this was something we didn't think that our customers would try and do, is there is an investment company which is our customer, and they have a big team of analysts who go through a lot of research documents to decide whether to invest in a company or not, or whatever could be the reasons. And they have a team of people going through most of the research data, public data, private data, data provided by the company, and then they take days to come back with the report. And then with AI for process, they were able to not just shorten the time that it takes to prepare this report, but the quality of report also was more improved with AI for process.
Okay, very cool. So if I'm a customer of Core.ai and I have, I think, my own development team, you said you have a low-code, no-code tool. So what is the experience like for a development team that's building a process or automating a process with your platform? What does that look and feel like?
Yeah, so what we have been seeing is that with generative AI coming in, the subject matter experts or the domain experts and the technology, the gap between them is reducing a lot. And we wanted to ensure that a subject matter expert who is aware of how to build AI agents with a no-code platform, build prompt engineering, using prompt engineering, they can build their own agents. So instead of spending time in translating their business knowledge in the terms which an engineer understands, express the same knowledge in the natural language to a AI agent, and AI agent understands those business rules or the functionality and builds it. So our platform is a complete no-code, low-code platform. At the same time, if you are a development savvy, we have SDKs for you to build using SDKs.
Okay.
But then yes, any subject matter expert can come in, start building the platform.
Okay. And how do you ensure that these agents that your customers are building are correct? Because correctness, I think, is one of the most difficult things when dealing with LLMs, right? How do I make sure they don't go off the rails? How do I know what right looks like?
Thanks a lot, Kyle, for asking this. I think I keep getting these questions asked by many of our prospective customers where they come to me and us and say that I can build these AI agents using a lot of open source frameworks, a lot of other no-code, low-code platforms, showcase a demo in 2 days or 3 days. Why would I buy something from Core.ai, right? I think building agents for demonstrations is very, very easy. But then testing them, evaluating these agents, when one agent is talking to another agent, is that calling the right agent or not? Is the right tool being called or not? Is it looping in the tool calls? What is the behavior? How do I trace what is happening here? And then evaluation of these agents is something which is very, very big. So we have invested a lot of our time, and we have a feature called Evaluation Studio, wherein you not only build agents, but you evaluate all these agents against different LLMs, right? So if I use OpenAI, what is the consistency at which these agents are running? Where are they falling out?
Right.
If I use Sonnet, how is it?
And how are you measuring that, right? I mean, how do I objectively decide whether Sonnet is better than OpenAI?
So we have come out with our own metrics, but then we have kept the platform open for you to come and add more of these things in rubrics.
Okay.
So something like groundedness, correctness, completeness. So initially when we started, for some of the banks, if someone would ask, what is the rate of interest of a fixed deposit for 30 days? Say the answer is some X.
Sure.
Which is correct. However, at least in India, I'm not sure of US, but it is not complete, because if you are an NRI, the rate of interest is different. If you are a senior citizen, the rate of interest is different.
Okay.
So just correctness of answer is not enough. Completeness of answer is also very important.
Got it.
So with typical RAG applications that you
We're talking about the distinction between precision and recall on some level, right?
Exactly. So there are a lot of parameters which you can define yourself on how do you rate a response from an agent is right, complete, or incorrect, or a partially correct.
Right.
So, and there could be some cases where partially correct answers is okay for you, but
Sure.
some cases partially correct answers is not right. So if you are looking for a troubleshooting guide of something and then it misses some steps,
Right.
then user is going to be
So
clueless.
is that example that you just gave of the interest rate question, is that from a real customer?
Yes, it is for one of our
And so
customers.
how are they able to eval that? Do they actually have a whole set of natural language evaluations and the expected answer
So
that are
there are-
consistently evaluated against the agent?
Yeah, there are two ways in which we do. We have built our own homegrown judge LLM models.
Okay.
However, we also encourage, because we are in that era, guys, where we sleep tonight saying we know everything, and tomorrow morning we wake up to something new, which
Right.
is completely amazing. So we don't want to claim that we have raised that, and so we kept the platform flexible enough for you to bring your own models also if required. So you can use either our judge models, or you can use custom judge models that you might have built for evaluating your AI
Okay.
agents.
Okay.
And then once AI agent gives you a report, a human feedback can also be provided, and from that, again, the LLMs can improve in their
Okay,
judgments.
cool. Tell us about your overall tech stack. You know, the tech stack for Core.ai. What are the what are the different components? What are the different stacks that you're using? What are some of the AI? It sounds like you're somewhat agnostic when it comes to LLMs, maybe, or embeddings providers, but maybe talk about any and all of that.
Yeah, so primarily as a technology stack, we are a React.js front-end, Node.js as a back-end, MongoDB, Redis, of course, for caching, and Python a lot for AI-related stuff. We started, say, providing embedding services. We have our own fine-tuned LLM for answer generation too. But then we realized very soon that we can't restrict ourselves to what we provide, because embedding models are also rapidly evolving. LLMs are also rapidly evolving.
Right.
So we provide some out-of-the-box embeddings, but then we allow anyone to bring your own embedding model, whether it is hosted by you, or you can bring your embedding model and host it with us too.
Oh, cool.
And then similarly, you can get your own re-ranker. We have our re-rankers, but you can also get your own re-ranker and re-rank the data.
Does everyone here know what re-ranking is? Because it was something that I learned relatively recently. Maybe, ish? Talk about re-ranking, because I think it's a really interesting concept that came about, when vector search and embedding models got big.
Yeah, so maybe I'll try to take a slightly non-software example, maybe a bit more Indian, so that everyone can understand.
Okay, perfect.
So most of us have written our entrance exams for engineering, like JEE and stuff, so for colleges, right? And all of us here, the first result when it comes in, it's the national ranks. This guy has topped the national rank 1, rank 2, rank 3. And then in few days, we also see that within Karnataka, this guy got rank 1. Within Telangana, this guy got rank 1, right? So now what the initial rankers or embedding models do is that they take all your embeddings against a given inputs, we generate embedding and then do a cosine similarity against, we also do hybrid search, so there is a reciprocal rank fusion which happens, but then at the end of the day, it is a top 100 ranks or top 200 ranks which we get. Now, what we do is we pick maybe a top 100 or top 200 out of each of these and then give it to the re-rankers, which are designed for re-ranking, but they are relatively slow. So if you give them millions of records, by the time you get the ranking, it will take minutes and not seconds or milliseconds. So we take only small portion of that and then give it to re-ranker so that they re-rank the data. And we have seen almost 10 to 15% of improvement in results if we use re-rankers. Again, both embedding models and re-rankers should be chosen depending on the data that you have and the languages that you want to support. So hence we kept it.
So re-ranking is taking disparate search results, effectively normalizing them across the same spectrum, and then coming up with a global rank.
Correct.
Right?
Yes.
Okay.
Yes.
So let's talk about context and context engineering, because that's something that Rowan highlighted in his keynote this morning. The idea of providing the perfect set of information at the right time to the LLM. What have you learned about context engineering or agent context in the course of building out Core.ai?
Yeah, I think Andrew Karpati has made context engineering as a home, every house's word.
Things move so quickly now, right?
Yeah.
The talk happened 2 months ago, and now everybody's talking about context
True.
engineering. But I think it captures something really central about what we're doing when we aggregate all of this data and get it into the right form.
True, true. So I think the reason why this came in is because the amount, LLMs are frozen. All of us know, I don't have to tell everyone with the knowledge that they have. So obviously what we are doing is we are augmenting it, doing RAG, either retrieving the information from your documents, your database, or different disparate systems, plus the memory. I think the way Rowan was talking about, there is memory that you are building during the interactions, past interactions, present interactions, all of that. But then all of that you need to fit into the context window of an LLM. And you need to be very clear as to what needs to be fed to the LLMs, because LLMs, while they have improved a lot, still have the needle in the haystack problem, hallucination problems. So we had to spend a lot of time understanding, though I am giving the entire information to LLM within the context window, why is it not answering correctly?
Right.
And there were high chances that the top few chunks, top 10 chunks and bottom 10 chunks were eligible for answering for LLM, but in the middle, some chunks were getting completely forgotten. And this is, I think, common for all of us, right? So whatever Kyle and me are speaking, I know maybe you heard initially something, you will not remember everything, right? The same problem LLMs have. They can't.
There is a quiz after this, so.
Yeah, so, and human beings also tend to listen whatever we are doing, but we keep summarizing in the back end and try to remember only the important words. And because that's the only processing power that we have. So context engineering is very, very key in terms of how we should do. We were doing it in a different way earlier, where we used to partition the context in a way that what is user's memory or user context, what is the same, what do you like, who are you, you are a male, what accounts do you have in the bank, what is your location, what credit cards do you have, this kind of information in the user. And we had a session context where we would store our current discussion, so whatever discussion we are having, so all of that, whatever is the summary of that, we would keep that. Then there is something called as enterprise context, where an enterprise knowledge base, which is common for all the employees or all the customers. Like, so for example, for when you are doing prompt engineering, you should have a persona of how your agent should behave with the customers, what is the personality of your organization, how should it handle the competition mention, how should it handle that. That doesn't change irrespective of who is going to talk to you. Such things go into the enterprise context, right? And then rest of the stuff has to be retrieved and augmented at the runtime. So context engineering plays a very, very key role and that's where I feel in the POCs everyone misses when they are building agents. How much of context to be sent, and if I'm running it with the same context 10 times, 3 or 4 times out of the 10 times agents misbehave.
Okay.
Right, so we need to be, that's the reason why we should not, though your capacity is to eat 10 chapatis, you should eat less so that you can accommodate more, so yeah.
Okay, great insights. Let's talk a little bit about the data architecture of the platform. Can you tell us, what does that look like and how have you scaled it over time?
Yeah, so on the data part, again, AI for work, the data architecture, how we store is different. For the AI for service, how we store is different because of the kind of customers we get. So we are, as a core.ai is, guys, we are a SaaS platform where multiple tenants come in to core.ai, register themselves, and then use core.ai for building your own voice agents or text agents. So we store a lot in Mongo. However, most of our data, which is recently used hot, is kept in Redis cache a lot. So we have built a lot of homegrown architecture for ensuring that data is also persisted in file system, and S3 is where it is not immediately required. Only when it is required we load that. Yeah, so, but most of the data is also encrypted. So we also, since we have large enterprises as our customers, we encrypt each tenant's data with their own key. So we don't use a common key for encryption of data.
Are you encrypting the data that goes into Redis as well?
Not into the Redis, yes, of no, but in the Mongo, everything in Mongo is encrypted.
Everything in the sort of system of record is
System
encrypted.
of record is,
Redis itself, it's not encrypted.
Yeah, because we keep only the hot cache in that, so the cache is evicted every time. So in fact, the bot definitions or the agent definitions, all of them are being cached in Redis.
So, talking about Redis a little bit more specifically, what are some of the features of Redis that you're using? If we can get into the details, what features of the Redis platform are your developers using?
So we have been using the open source Elastic Cache earlier before Redis, and then we were using JSON objects because as I said, we were creating memories or context for each user session and enterprise. So we had to maintain them in large objects, which was JSON objects.
Yep.
And when JSON is a data structure that we have been using for a long time, and then at Redis too, we use JSON objects a lot.
So you recently switched a lot of your infrastructure from Elastic Cache over to Redis Enterprise and Redis Cloud. Talk about the reasons for that. Why did you do that?
Yeah, I think being an engineering company, we felt that we should manage our own infrastructure. We can monitor, we can ensure that there is no downtime, latency issues. Because we are engineering heavy guys, and all of us are confident we can solve. But then some of our customers like Cigna and CVS, they are having huge calls, and there are spikes during their festive time or their insurance renewals and all of that. And we had to put a lot of our energies on planning for the scale and then downtimes, and any delay in that was leading to a lot of cost that we were handling. So we felt, yes, while we are engineering heavy company, this is not the core engineering that we want to do. So that's when we spoke to multiple vendors and then chose Redis for migrating to that. And the best thing that Redis offered that time was zero downtime of migration from Elastic to Redis. So all our in-flight messages were also being synced. So we actually.
So it was more for you. It's more about ease of use and reliability than about cost reduction, or is that not necessarily true?
No, while I would love to reduce a bit more cost, Kyle.
Yeah,
but
we're working on it.
we have almost reduced 40% of our cost
Okay.
After migrating to Redis.
Awesome.
Mostly because we were leaving a lot of servers unused. Now they are being properly managed, and then we are able to handle it better.
And so anything happening next with Redis, I think we've talked about vector search a little bit on our own. Is there an opportunity for that in your platform?
Yes, so we have been working on building homegrown solutions a lot on search, because we have something at bottom, but we have written a lot of infrastructure on top of that. Especially for agent memory too, we have built a lot of our own infrastructure on top of that, where we don't want to spend more time there. We would love to, actually we are working a lot with your engineering team and your product management team to, we have given a lot of feature requests to understand, to cater to our needs, and we are looking forward to use Redis search and memory both.
As much experience as you do in building agents, right, specifically. So, what do you see as coming next in the world of agents? What are the next interesting challenges that you're looking forward to solving there?
I think I guessed this question some time back, and then that's the reason why I prepared this slide.
Oh, perfect.
So what we are going to see, I'm sure most of you have come here, but next year when you come, what you are going to do is build your own AI agents who are going to do what you are supposed to do sitting at office, and keep attending such events in the future, right? So most of us will have our own agents built by us or by our organization. There is a lot of work going on where even an agent is going to get an employee ID with roles and tasks assigned to them.
Do I have to worry for my job in that case?
No, I think we'll have, all of us will have our jobs, but just that we'll be leveraging AI instead of anything else. So, and if you are participating in our Zoom or Google Meets, maybe there are some other AI agents who are interacting with us, working with us, raising some pull requests along with us. So what we feel is that is inevitable. We will be building AI agents to do our jobs, whether it is at work or at home. There will be a lot of AI agents built by our companies which are running 24/7. Now, there is a need for governance of all of this. For each of us, there is a manager who is overseeing us, rating us every year in our performance appraisals. Whether money it's turned into money or not is different thing, but we are being rated. We are given a feedback. Now, who is going to monitor these agents, give the feedback, identify the drift, escalate it, right? So if you misbehave, your manager escalates it to their manager. So there has to be someone who is governing all of these things, observing all of these things, and evaluating them and correcting them wherever required. So we envision ourselves becoming an operating system of all of this, where whether you have built an agent on core, whether you have built an agent on crew or LangGraph or anywhere, but then we want to be that platform wherein your company is observing all the agents that are running, monitoring them, correcting them in the language in which you speak, not in the code.
Okay.
Cool.
Fascinating.
I think that's what we are thinking of.
Great. I think we're pretty much at time here. Did we have a moment for questions, or are we totally out? Does anyone have a question they'd like to ask our distinguished panelist today?
Yes, sir.
I think we might have a microphone right up here in the front.
Until then, all of you please visit core.ai website.
I think at this scale, you have been facing this cost problem as well, right?
Yes.
So what are the ways to optimize the cost, especially the LLM cost?
So I think this is a chicken and egg problem, guys. So unless everyone wants to leverage LLMs, even for smaller calculations now, no one even wants to do 2 plus 2. They want to delegate to ChatGPT. So, all right. So yes, definitely LLM costs are higher once you are in production, especially when you are building AI agents and running in loops. While it's very nice, it's very costly. It's like maintaining a Ferrari that you are going to have. So there are a lot of techniques. One is definitely context engineering that you would use for anything which is static data, which is not going to change frequently. We would recommend you use caching, like LangCache, or build your own cache. I mean, there are a lot of other caching techniques, but LangCache can be a very good opportunity for you to cache the responses. But we need to be very careful when we are caching. We need to be understanding the small factors, like say an employee asks, how many leaves do I have? The answer for that changes depending on the gender, depending on the country, depending on the location. Within India, the leaves are different, the holidays are different in Bangalore versus Hyderabad versus Chennai. So you need to understand, because you can't give an answer for US employee the holidays of India, right? So you need to be very careful on that. So, but caching is definitely one of the techniques that we can use. Leverage the best practices of LLMs too, because LLMs also are providing some of the caches, but that is more of a prompt caching. Ensure that you leverage that, because this is one of the anti-pattern that I have seen. Many people put the dynamic content at the top and the static rules or business rules later. That will not help us, because we are not taking advantage of Anthropic's or OpenAI's caching technique. So if you put most of the static context, system context at the top, and add only the dynamic information at the bottom, so we'll reduce cost there too. It's not just cost, it's the latency too, right? So if the higher number of tokens you give to LLM, it takes, because they don't remember, right? So it has to process each token that you give. So yeah, memory also, when you are adding memory.
Right, this is kind of the context window problem, which is that even if the window is massive, you want to use as little as you possibly can to avoid latency and costs, right?
Yes. So the biggest problem that we are seeing with a lot of our customers is also the latency, right, with different models. So you don't want to send a lot of data to LLM, because it is unnecessarily processing also, right? So you don't have to.
Very good. Another question for Girish?
Yes, sir.
We have somebody right here in the front. There's a microphone coming your way.
So you have AI suits for all kind of different domains. How we are managing security and sensitivity of the data so that it won't get exposed to over the world?
Yeah, so one thing is all our data is both encrypted in transit and at rest using the tenant's key. So each customer gets their own key for encryption of data. Second thing is the PII data anonymization. So we have built a SLM or a small language model to identify the PII information, which is hosted by us. We anonymize the data, we don't redact. We anonymize the data and send the anonymized data to the LLM. And once the response comes back, we de-anonymize and then send it back. So the choice of choosing an LLM also for a small LLM for this is also to ensure that the latency is also very minimal. Because PI data like credit card numbers, email IDs, phone numbers can be identified with regular expressions which are very, very fast. But then some customers also want, they treat their first names and last names also as PI information, which is very tough doing natural language processing too, because when many of you are cricket fans here, so John T. Rhodes' daughter's name is India. Now it's a person name or a country name, identifying that is very difficult, right? So while country is not a PI information, person name could be a PI information. So hence we have chosen to also fine tune SLM for that. But yeah, to answer your question, anonymized data is sent to LLM and de-anonymized data is sent to the user and everything is encrypted at rest.
So LLMs or SLM, small language or language never come to know what kind of data it's, means from where is the source and what is actually doing?
No, they don't know. They don't know at all from where the source is, right? So all of that is kept at us. We give it only the chunks or what the pieces of information and ID that we have created, so that when they respond back with the ID of the chunk from where it has got generated response. And we again reverse map it to the actual source document. And we never share any links, any URLs or anything to LLMs. All of that are persisted at us, and that is our job that we do.
Okay.
Thank you.
Thank you.
I think we have time for one more question. If there's someone who has one?
Yeah.
How about
this side?
Down here on this side, yeah.
I have mic here.
Oh, you have your own. All right, let's do it.
This
Wait,
side.
where's the person coming from? Oh,
Yeah,
there they are.
yeah, yeah.
It's the voice of God.
Correct.
Right.
Hi, Girish. So my question is around LLM's output validation in context of business domain. So as we know, if I'm asking same question, I will be getting somewhat different answer. So in your setup, how do you ensure correctness and groundness of response from LLM or agent?
Yeah, so I think this is also something that is very important for all the QA engineers around who have been traditionally testing equals to, is the value equals or not, kind of a comparison to mature now to test how the LLM responses will be. But then LLMs, like judge LLMs are also trained for these kind of things where when you create the golden data set, you also mentioned what are the values that you are looking for. You don't have to say that rate of interest for 180 days for a regular citizen is so and so, for senior citizen so and so, for females it is so and so, because now there are some schemes even for females. So you don't have to be very descriptive, but if you can mention the data itself and ask the judge model to check if the answer has all these things or not, right? So then the judge LLMs are able to handle those things in variations of the languages. There can be a judge model to check the sentiment of one of the metric could be, is the sentiment right or not? Another metric could be, are the values correct or not? Another rubric metric could be, is every value covered it or not? So if someone has already mentioned, I am a senior citizen, what is the rate of interest for 180 days? You don't have to give the rate of interest for a regular citizen or a non-resident Indian. You just have to give for a senior citizen. So judge LLMs are able to handle all of this, or you can fine tune a model with either with prompt engineering, or you can fine tune a SLM for doing that.
Right. So in that sense, you are saying that LLM as a judge should be grounded on your business context, there should be some human in loop to validate throughout the, and another thought around is these responses, because we are operating in business context. So this year that's valid, but next year it has to change, right? So because of regulatory or because of anything, so how we can deal with all this?
With Trump changing tariffs every morning,
one of the great examples.
The values, the data also keeps changing, so we need to keep evaluating also every day. Yes, the SMEs have to go and correct that, sorry, I missed your actual question, but then yes, you have to go and there can be a source where you mention what are the actual values that you are giving, and then the LLMs we can use LLMs for, the human feedback thing, right? While human feedback is very important, I think slowly it is going to be very, very tough for us to also add human feedback with so many agents. Today you are building just 5 agents, 10 agents, 20 agents. Tomorrow you will have thousands of agents. How will you humanly evaluate all of those things? So you have to use another LLM, but what they can do is they can not just measure the output, but they can also give the confidence with which they felt that this is right or wrong. And only that cream of anomalies can be evaluated by a human feedback.
Great.
Yeah,
Girish, this has been amazing. Thank you so much for sharing your wisdom and experience. We really appreciate it. How about a round of applause for Girish, everybody?
Thanks a lot. Thanks a lot, Kyle.
Thank you so much for coming up.
Thank you,
All right.
Redis
Thank
team,
you, everybody.
for calling me.
just curious. Oh, no, check. Now we can't have a conversation.
question in your mind then? Is there a question in your mind then? Is there a question in your mind then? You can be free. Somebody asked me, just be ready so you can be free. Somebody asked me, just be ready so you can be free. Somebody asked me, just be ready so you can be free. Somebody asked me, just be ready so all I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm spirit in my soul. I can feel is warm
translate करता है. If you want to translate from Spanish, Italian, random languages. Chinese is not there. It's the best option. You guys are the front row.
it on? How's everyone doing? Yeah. We got the last session of the day here. I'm convinced it's the best session of the day. So why don't we get going? No, I'm fired up for this one. We are going to talk to Apna, okay, about obviously scaling from 0 to 60 million users in a very short period of time. So I would love to welcome to the stage Abhishek Ranjan, Head of Engineering from Apna. Abhishek, where? There you are. Nice. Whoa.
Hey,
Abhishek, how are you, man? I'm fired up to have this.
Yep.
Good day so far?
Yeah, great day.
Yeah. Before we get into the script, what was the best session of the morning? What's the best session of the day been thus far?
I think the Langcash session was pretty good.
Yeah.
Yeah, I mean, that was the best. I think makes sense to a lot of work that we want to do. So yeah, that was the best.
Cool. We got to get you on that then soon, right? How about we do this? Let's just break this down a little bit. How about you introduce yourself, a little bit of your background, and then we'll get into Apna. Does that work?
Yeah, that works. So hey, I'm Abhishek. I head engineering for Apna. Apna is India's one of the fastest growing jobs and opportunities marketplace. Today we have over 60 million users on our platform. We get 1 million daily active users who apply for jobs. Every day we give thousands of jobs to different people, make their lives better. And we have grown pretty fast. We're still a young company, only 4 to 5 years old. We were one of India's fastest unicorns. And today we are catering to 1 million users, giving them millions of jobs every month.
Cool. And why don't you just dive a little bit deeper into Apna, right? Just so we understand exactly what the platform does. Is that cool?
So yeah, so Apna is a jobs and opportunities platform. We started in 2019 as a platform to organize the unorganized sector in India. So 6 years ago, if you wanted to, let's say, hire a delivery boy, a driver, a gig worker, a carpenter, it was almost impossible for you to hire these people, right? Even for companies and for people like these to find the right jobs. I remember, I mean, you could walk around in the city and you would find some pamphlets stuck on trees and walls where people would say that a driver wanted. And even for companies, international companies like Uber, etc., it was very difficult for them to find these people. So that was the idea, to make life easier for these people as well, to find a community for themselves, find the right jobs for themselves, and see their career grow. And also for companies to hire the right people, have a central place where they can come. So this is how we started, this is how our journey started. From there we have now grown significantly. We have gone into different markets. Now we cater to all kinds of jobs. So if whether you're a delivery boy trying to find your next gig in a Swiggy or a Zomato, or you're a software engineer trying to find your first job or second job, everything is available on the platform today.
Wow. So that's a breadth of kind of what you're doing. And you talked about 60 million users and all those different job opportunities. Like, how do you kind of get the right information at the right time to the job seekers? How do you get the qualified opportunities to them?
So the way we approach a problem, and the problem that we solve is slightly more complex than any other platform solves because of the sheer breadth of job roles and opportunities that we offer.
Yeah.
So you can start with a delivery boy, you can go up to a software engineer. There are people who don't know how to fill a profile, and there are people who know it very well. So how do you recommend them the best job, I think, and also recommend employers the best people that they should reach out to, because there will be thousands of people who apply to a particular job, and you always want to reach out to the best, right? You might not always have the bandwidth to reach out to all of them.
Of course.
So these are two problems that we are trying to solve in the marketplace situation, where there's employer and there's the candidate. What we have done here is we have built out recommendation and search is where we drive a lot of this today. So our recommendation engine is built on top of our embedding model. So we have fine-tuned our own embedding model based on a lot of jobs and application data of kind of people getting selected, what kinds of jobs people like. All of that data that we collected, we have trained it and fine-tuned our embedding model, which allows people to find the best job. So in real time, we do a vector match. We have our own ML model, ranker, re-ranking layer after that as well, which allows people to find the best jobs. And similar thing is done on our search as well. So when people try to find the next job, they'll be able to do it. Today we have our app and our website. Both these platforms are available completely free for the candidate, where they can come in, use our search and recommendation algorithms to find the best jobs that works for them.
Cool, awesome. So obviously we got you on stage to talk about Redis, but let's kind of go kind of pre-Redis, if that's okay.
Yeah.
When you were in the market at that stage looking at Redis, what challenges were you facing, and kind of like what were you looking to solve before even getting into Redis?
So Redis was actually part of our stack from day zero.
Okay.
Right? I mean, when we started, a lot of our senior engineers, everybody had worked with Redis. In the caching world, Redis is cache, right? I mean, I don't think you can think of too many other solutions. We take so many interviews where people write skills as Redis caching, right? I mean, so caching, for caching, Redis was always a part because we knew it was reliable, we knew how it worked, and everybody had used it. As we were growing, as we were building out more features, the first thing that we saw with Redis was 2-3 years ago when we started our vector journey. We actually started with a different provider because there were a lot of vector stores in the world. The popular ones, we started with them. And we rolled it out to 5% of our users. As we rolled it out to 5% of our users, we realized that there was and it worked well for 5% users, and then we rolled it out to more for about 10%. And then we saw that there was a huge latency. It was a Friday afternoon or a Friday morning at that point of time. And we had two options. We could either roll back and like redo this whole thing, but we didn't really want to. So we decided that why not just try migrating this into Redis Vector, and then we'll see how it goes. So one weekend, and we did migrate a lot of it to our Redis Vector, and we saw significant difference in latency. Today we have it rolled out to 100% of our user base, everybody uses it. We have significant uptake in terms of our business numbers. We have significant uptake in terms of people who are selecting the right jobs and recommendations. And our latency is almost like 1/6 of what the other providers were offering. So that's what led us to choose Redis for the vector store. Now we have also started using Redis for some of our streaming use cases, and a lot where we have migrated from the more popular ones to Redis, where again we are seeing similar gains. Apart from that, we've had great relationship with Redis in terms of support, in terms of helping us build what we want to build. So yeah, I mean, overall I think that's been our journey with Redis.
Very cool story. So just so we got that right, a Friday afternoon,
Yep.
a live migration to Redis Vector, 6x performance improvement, and we've been powering the engine ever since.
Yes.
That's pretty awesome. Maybe we can actually move to the infrastructure. Does that make sense?
Yeah, it makes
I
sense.
think you have the clicker because I don't
Yep.
have the clicker. Hopefully one of us has a clicker.
Yep.
Okay, maybe you can walk the crowd kind of, obviously you just walked through in a high level, but let's like go under the engine here and walk us through this entire architecture.
So I'll pick up some of the important parts. Of course, we have our app and our website where our searches, our recommendations, all of it is powered by Redis. Of course, you have other components of API gateways and everything else that is there. But I think the important part here is to understand that what we use Redis most for, and that is sort of the brain of our overall recommendation system and everything else. So Redis acts as the main vector store for our embeddings. All the user profiles, over 60 million user profiles, millions of jobs get embedded in this, and real-time recommendations happen on top of this. We use our own embedding model, which allows us to sort of generate very, not our own, but a very fine-tuned version of open source embedding model, which allows us to give you very accurate recommendations and the kind of jobs that you would really get through and what you're looking for. We use HNSW inside Redis. One of the things, since the volume of entities that we have in Redis is high, we had multiple options. We could use flat, we could use HNSW, we could use cosine similarities, a bunch of these things we could use. We decided to use HNSW. When we first did it, one of the challenges we foresaw was that maybe the recommendations would not be the most accurate because it's internally creating a graph of itself of nearest neighbors, and if you want to go further, how would you do it? But overall our experience has been great. We have not had any challenges with accuracy. Our accuracy is very good, and the latency is super high because it's all in memory. It allows you to traverse the nearest neighbor quickly. This taxonomy engine is what powers everything, right? So imagine this like a big vector space which consists of job titles, skills, industries, companies, roles, and anything that you can think of in the jobs ecosystem, and how these things are related to each other, how these things are, how can you traverse from one place to another. All this sort of lies in this vector space. And this is what we are using Redis for, and that sort of primarily powers our job search, job recommendations. What we also do apart from this is it also does our suggestions. So when you're creating a profile or you're trying to write, like let's say you write skill as a Java developer, we want to recommend that you can also search for things like backend developer or a database developer or PHP developer. So all these again flow from Redis, the taxonomy engine that we have built on top of Redis. So this is sort of this architecture. Beyond that, what we also do is we use it as ML store for feature store for our ML models, which get trained real time in terms of what data is coming in, how people are applying.
Cool.
So and that makes it a lot faster in terms of how we can deliver to our customers. Because one of the challenges that we have is that since we cater to the breadth, we have people with 2G, 3G connections sitting in a remote area with a $5,000 phone, and we have people sitting with a 16 Pro, 17 Pro Max running on a super Wi-Fi. So we want to cater to both, right? I mean, we want to have a feed that is fast, so it should load fast and quickly, because in today's world, I mean, if it doesn't load fast, people just disappear and look for the next platform. So that's an important factor for us. And each second or each millisecond that we save, it's important. That sort of gets people more jobs, right? I mean, because essentially getting a job is always a race. Who applies first, gets the call first, gets to the interviews first, and so on and so forth.
Very cool. So you walk through the caching layer has always been Redis, right? But obviously we walked through kind of the vector layer, we've walked through even the Redis streams and the pub sub. Like maybe just give us a little double click on what you were using in those areas before and what the main challenges were before going to Redis.
So a couple of challenges. I think vector we've already talked about. We tried almost all.
Okay.
Quite a few vendors, not all, I would not say all, but we tried quite a few vendors, and everybody said we are faster.
Okay.
Like that was, when you talk to them, everybody tells you they are faster. Everybody has their own benchmark, everything is faster in their own world. It's like the models today, everybody beats other one in their own benchmarks. But
so you're saying don't listen to the marketing?
No, don't. Listen to ours.
Okay.
But so that was one of the challenges in terms of vectors. When we tried Redis, it was our latency reduced from close to 400 to 500 millisecond to the order of 40 to 50 millisecond, which was a significant change. And I'll tell you why. Because when a feed loads, vector matching is one part of it, and then you do other heuristic business matching on top of it, which adds another few seconds. So if your vector matching itself is taking 500, 600 millisecond, you eventually load the feed in 1 second or whatever, right? Which is a significant amount of time. When you reduce it to 50 millisecond, your overall sort of latency comes down to 100, 120 millisecond, which is what we were looking for, a sub 100 millisecond latency. And that's what Redis allowed us to do in terms of when we were building out our vector store with Redis. Now we have also sort of moved on and built other things on top of it, like RAG and other things, where also the latency has been significantly higher compared to other things. Even on the stream side, we have had, we still use a bunch of other things, but we've also started moving a lot of that load to Redis. I think where it has given us significant advantage is the combination of speed and cost.
Okay.
So the latency in terms of streams is not such a big issue, but because I mean it's anyways processed asynchronously, but I think cost-wise and reliability-wise, it's been a big advantage for us.
Awesome, cool. So we've hit a lot on kind of the speed, the performance, and the technology stack. Let's get to the business outcomes, right? What were the business outcomes that you had through Redis? How have you been able to articulate that through others in the organization?
So one of the most important metrics that we track as a business is the number of leads that are getting created for a user, right? So for example, if somebody goes and applies to one job, it is considered as one screen lead.
Okay.
Now this is an important metric because it eventually drives everything for us, right? Whether the more jobs get applied, the more employers get candidates, the more people get shortlisted, eventually we make more revenue, right? So it's a revenue driving metric and one of the most important metric, sort of the core metric that we want to track. So in this particular case, when we did launch our vector embeddings, our screen leads improved a little bit for the cohort that we launched it for. When we scaled it to more, it sort of dropped because the latency became higher, the drop-offs became higher, not many people were applying. When we moved to Redis, which was pretty quickly on the weekend, after that we've had significant increase in the number of screen leads that we have got, almost in the order of 30%. So
north of 30% increase in screen leads since putting Redis vector in. Cool.
So that was one of a very important factor for us. It allowed us to sort of get more screen leads and also get more people connected to the right employers. Sometimes because of a technological glitch, you might miss out on a great candidate, right?
Yeah.
That no longer happens.
So it's the screen leads and it's then obviously getting the employers with the right job candidate as well. So it's both those business outcomes. Cool. Okay. You talked a little bit there about cost when we were talking about the stream side, and we were just talking about business impact, and we all know there's a cost element to it. How do you manage performance and cost at the same time? Like, how do you look at that and how do you manage that?
So cost is an important aspect for us. We are in a cost sensitive market in India, and it's important for us to be cognizant of how much we are spending, right? It's easy to just keep scaling the systems, and you can keep horizontally adding machines, and someday it'll always serve, right? You can always scale. So the challenge for us always has been how to manage or balance cost versus the performance that the product that we are getting. In this, I think Redis has been great for us. I mean, we've had significant reduction in cost when we moved to streams from the other provider that we were using. Cache has always been Redis and has not really been a problem for us. One of the learnings that we have had in our journey, and we like many others have gone through our journey of starting with self-managed Redis, moving to cloud-managed Redis, memory store, one of these things. And then eventually, from the last 2.5 years, or almost 3 years at this point, we are on Redis, Redis Labs.
Yep, Redis Enterprise.
Yeah.
Yep.
So, and our experience has been that the Redis Labs gives us the best cost outcome, because it allows us, because when you're looking at cost, you don't just look at the cost of the software, right? I mean, you also look at the management cost, the number of people you have to put in, how many people are there continuously looking at it, the number of hours lost, right? So including all that, I mean, it has been a significant gain for us to move into Redis Cloud. I think that has been one of the best decisions for us over the last few years. And it allows us support, it allows us reliability, overall cost is under control, and you're not worried about managing the system, right? So that's been a great thing for us.
Awesome, cool. So I guess we've walked through 0 to 60 million, obviously an incredible last kind of 4 to 5 years at Apna, and then we walked through your maturity of this kind of technology stack, right? We got people in the room, I assume, in all different kind of aspects of the journey. What are some of your biggest lessons learned over the last 4 or 5 years? What would you maybe do differently now, knowing what you've been through?
So there are two things that I would like to tell people today. I think one is when you're building out a new system, you're building out a startup, I think one of the most important things is optimism and sort of falling in love with the problem that you're solving. If you're optimistic, I mean, you will eventually build it. Like, you cannot be pessimistic about your own thing from day zero. So optimism is the most important thing. The second most important thing, I think a lot of times we miss, and we used to get it a lot of times as well. Like when we were building out, a lot of times we would get advice like, build it however you want to build it, the cheapest. And then when you grow, it will become a rich man's problem. Is a comment that we got from some of our people. And then, but we actually grow pretty fast, so we did not really have the time to solve it. And then you have a lot of weekends and everything, right? So I think one of those things is, the second thing is to avoid any decision paralysis. Choose the best solution that you have on day zero. Look at a little bit more long term. Don't worry about too much about benchmarking, figuring out a lot of things, because as a startup you might not have that time on your hand, because you're also incurring market debt while you're waiting for it. So look for the best solution. I think if I go back 5 years, I would probably start with Redis Labs and not self-hosted, and then move to Redis Labs eventually. Sometimes it's also the engineer's ego, right? You want to do everything yourself. I think you have to keep that aside as well. So yeah, I mean, optimism and bias for action, I think these are two things.
I love that. Optimism and bias for action. We can all take that into our lives, right? Not just work. So cool. So look, you've had obviously a great 4 to 5 years. Like, talk to us about what's next. What's the future here for Apna?
So Apna started as a platform which was providing workforce to people. We want to continue doing that. We want to enable more and more people to have better jobs and find the best jobs that's suitable for them. We are adopting AI in ways that make it easier for both our employers and candidates. Our two recent products, one is our interview prep product, where you can actually go talk to our conversational AI agents. It will actually do a full mock interview for you, give you a report, tell you what goes wrong, what goes right. It's like as if you're talking to a human. It's available on platform. It's a new launch that we have had great success with. We also have an opposite of this on the employer side, where we have a recruiter who would actually go take interviews, screen candidates in the first round. So it makes it easier for our employers, especially for bulk jobs, where you have thousands of candidates, you might want to hire 10. It will screen, get you 20, 30, and you can go ahead from there. Here again, we are using Redis for a lot of memory in our agents, which has been an important thing. Because in conversational agents, it becomes even more important that it's fast. Right? You cannot wait after you've said a sentence, you cannot wait on the other side to wait and then respond. So Redis has been instrumental here as well. What we have also done more recently is we have almost clocked close to 30 million minutes of conversations on these agents across the two. So we have scaled dramatically here. I mean, I would talk about the Redis hits, which are also significantly high. I think in some of these use cases are where we are moving towards. We were one of the first people to start actually fine-tuning our own embedding model and getting to the right place in terms of giving the best recommendation. And we want to continue doing that as we move forward.
Cool. So that's awesome. What's next for, I guess, Redis within Apna? Where do you want to bring Redis next? Where do you want to get more capabilities out of Redis?
So in terms of Redis, I would say in the agentic world, I think Redis sort of stands at a point where it might just become the memory layer for all AI agents. That's where I fundamentally see Redis being better than anything that we have today. Essentially, all AI agents will need some kind of memory. They will need a context and a context engineering background behind them for them to do their job better, to hallucinate less, and to take actions without iterating too much. I think that's where, and a lot of things are coming. We talked yesterday about Langcache and the open source project, that sort of builds a more higher level memory on top of it. I think that has been, that's where I think the future will take Redis, and I think it pretty much stands as the most important player and thing in this space.
Very cool. Thank you. Let's see how the audience is doing. Anyone got any questions for Abhishek out there? We do have some.
Yep.
Do we have a mic by any chance? I can't see anything, so.
I can see the.
I think we have a mic coming your way. Just give us 33 seconds.
Yeah, hi. Am I audible?
Yeah.
So actually what I see that AI only helping us to write our resume and then AI only helping HR to scan our resume. So it's a cycle going on. Both way AI only helping. Now my question is like sometime when we start getting a profile and getting it shortlisted, post that it takes around 1 month or 2 months of time to get a final offer letter. So how Apna can help the recruiters to bridge or reduce that gap so that sometimes what feel that the user is not getting the communication also, okay, and he's keep on calling, chasing HR and all that where it is. So how Apna can help the recruiters to reduce that gap and keep on informing the user as well that this is how the stage, the current process is going on and how we can overall reduce the turnaround time from the shortlisting to the offer letter.
Yeah, this is a
good question.
Very good question.
Yeah, cool.
I think this is one of the problems that we have tried to solve with something that we have released a month back. It's rolled out to some of our employers, which is our AI recruiter. So, and we have also piloted it with a bunch of other enterprises who are using it. So what it allows you to do, so the problem today is, especially if you are in the bulk hiring space where you get a lot of candidates and you want to hire a few out of them, the challenge is that there are 2 recruiters, there are 200 profiles, they will process in whatever speed they can process, and sometimes what happens that if the 20th person is okay, they would not really move behind and look at the 1000th person there, right? So that's the problem that recruiters face today, because I mean you also want to close your rec quickly. That's the problem on their side as well. So what we have done with AI recruiter is it is like a recruiter which is always available for you. It will call you, it will screen you, it will figure out if you fit basic things which are not there in the profile or which are beyond resume. Like for example, if it's checking your basic skills like programming or English speaking or any of these things, it will also talk to you about salary, whether you're okay with that, understand that, whether you fit in our budget. It will do the screening round for you. Then it will shortlist you, send it to the candidate. The recruiter will also be always available, so you can chat with that AI on WhatsApp, on email, you can call it, and it will always give you updates where you stand, where you not stand. In fact, there's a very interesting anecdote. We did it with one of a big companies in India a few months back, and we had a lot of conversations with our AI because the recruiters had stopped picking up phone. But the AI recruiter would still pick up and tell you, okay, your status is this is where we are at. We had long conversations. I mean, we had interesting conversations as well. But that's where we are heading. We want to make it easier for people to also know where they stand, and also for employers to be able to scan the whole pool rather than stopping at X rather than whatever the full number is.
Yeah.
Thank you. Thank you.
Great question. Thank you.
Thank you.
I think we got another. Get ready. You got them coming.
Yeah.
Thank you. Yeah, that was nice architecture as we see. I have a question around the architecture where 2 things, right? If you can bring up the PPT.
Can you go back to the architecture? Here, I'll take that. You listen. I'll try to do this.
Yeah, go ahead.
Okay, so yeah, till it comes, I see that there is a lot of scope for having a cache on top of the job searches what we have today, right? One thing what I wanted to ask you on terms of the challenges what you have is like, the job searches are fine. If I can search for a doctor or an engineer or a practitioner, whatever it is, right? Caching those things it's a common cache where I can easily cache those things. But how do you make a personalized touch on top of it, bringing in the recommendation based upon my profile, because my profile is entirely different based upon your profile. We both may be searching for a driver kind of job, right? So how do you bring in the personalized touch on top of the cache, right? That's one thing. And yeah, maybe the second question is related to how frequently we invalidate cache, because that is something that which we should not give a false promise telling that I show 10 jobs and when I click on that, then it should not tell that, hey, this job is expired, right? So how do you, because in the caching world, I see that invalidating caching is the biggest challenge, right?
Yeah.
So when do you do, and what is the strategy behind, or how do you do this?
So let me, like, see, this is the common question that we get a lot of times, because like when you talk about Redis, you think it's cache. So how we do our job recommendations today is, actually we don't cache anything there. Redis is primarily not used for caching as such. I mean, it is used to cache some things like common job roles and a bunch of those things, but for recommendations, it's not caching the recommendation for you. So what we use Redis there for is like a vector store. So imagine that you have millions of jobs and your profile. From your profile, we create a vector, right? A vector, a very dense vector of 1024 dimensions. We create a vector out of your profile, and similarly we create a vector out of the job as well. Now when we create these two vectors, this is done using an embedding model that we have trained on what kind of jobs people apply to, what profile gets selected, what profile doesn't get selected. It's trained on a lot of job data that has been there on our platform, a lot of click data that is there on a platform. So what it does, it is allows you to do a real-time comparison whether what is the best match, right? Between these two vectors, what is the best match, and then we apply some heuristic business logic on top of it in terms of which is the premium job, which is the premium user, a bunch of other things like some strong matches like location, experience, which are not through vector, which are just a general match. So we don't use it primarily for caching. We use it primarily for creating this, matching this vector where it's a lot faster. So it's more or less used like a vector database here and not caching. Coming to the second question, which is the cache invalidation. So all that happens real time for us. When a job gets posted on a platform, it flows into the database, it gets added immediately, a vector gets created, and it will be almost near real time available for you to match. Similarly, when a job expires, it's auto expired, expiration event gets triggered, which invalidates the cache and moves it out, invalidates the database and moves the job vector out of that particular thing. We also have heuristic logic, so even if it doesn't get expired, you will always get only jobs which are active at a particular time. You will not ever get inactive jobs. One of the main things that we do is we want to have a system where every user has availability to every job. So we don't, so it's not a system like, let's say, our Twitter or X, sorry, where you pre-compute feeds and the pre-computed feed is kept. It's always real time, as real time calculated. That's why Redis is important for us, because it allows us to do this real time calculation quickly. Otherwise, it will take a longer time.
Awesome.
Yeah.
Cool. Any others? All right. Well, look, Abhishek.
Yep.
Thank you, man.
Thank you.
First off, the last couple of days have been great to just getting to know you, and really appreciate you spending time. I think everyone enjoyed it, and also from the Redis perspective, thanks for the partnership.
Thank you so much.
Awesome. Here, give it up for Abhishek from Appner. Awesome. Cool. Look, I think that's it for at least the sessions and everything like that. So huge round of thanks again to Abhishek, but more importantly, we've got a, I think for the next couple hours, right? A happy hour out there. I was told to let everyone know there's a race car game, okay? And the winners of the race car game win prizes, okay? So someone from this room has to win that race car game, all right? All right, thank you, everyone. We'll see everyone out at the patio, okay?
Thank you.
Thank you, man. That was great. Yeah, really appreciate it.